Okay, what I want to do is do an overview of the rules covering different aspects, and basically what I consider is the cursory review or a very quick rule. When we go through these, anything that's highlighted in red is going to be international only. And again, the exam you're taking is going to be inland and international rules, so there's no coal regs restriction on the license, which is very important. The first aspect of this, when we talk about rules and what you may have seen when you've gone through them, is that they only make sense if you're on a bigger boat. Guys that are on their 18, 20-foot Rangers don't seem to understand why they can't do certain things. But if you put yourself on a 60 to 80-foot boat, 100-foot boat, then it seems to make a lot more sense, both with lights and maneuverability, et cetera. So always think of yourself on a larger boat, very critical. The next thing is rules are legal definitions, and they must be applied exactly as worded and not how you think they should be applied. The classic one is we go down on the starboard side of a river. Most guys drive down the middle and they'll tell you, well, I drive down the middle. That's awesome. But what does the rule say? The rule says you will be starboard, safe and practical. What do you think the answer is going to be on any exam? It's not going to be down the middle. So again, you have to think of these in black and white. How you apply them on the water and the reality is totally different. That's the biggest thing. Rules are one thing, reality is another. Example, speed limit is 25, but everybody drives 35. What does the law say? It's 25 miles an hour. So again, always think of these as black and white and you'll do fine, especially with the answers on it. The purpose of the rules. Why do we have rules? To avoid collision. If there was no issues with collision, why would we have rules? So again, rules are there to avoid collision with other vessels or other objects. So the key thing is, why do we have them? Avoid collision. When do we apply them? In case of a collision. Okay, the rules are divided into inland and international. And that is done through a demarcation line, which we can see on our charts. And on the Long Island chart, it'll be over on the right side. And basically, it's going to say anything that's inside that is our inland rules. And some of our inland rules are different than the international rules because we want them a little bit different. However, on the outside of it, out on the high seas, our international rules are what's been accepted by, I think, about 186 different countries of it. So we have international rules and we have inland rules. Coal regs, because it was in 1972, they had a convention on the prevention of collision. So that's where we got the coal regulation rules, or the coal regs. Inland, what we did is consolidated a number of archaic rules and regulations into one package. So no matter if you're in Minnesota, if you're in California, down in Puerto Rico, they're all the same. Consistency. There are 38 rules, 5 annexes. We're only going to talk about one of the annexes. The other ones deal with the technical aspects of what is sound, what is a light, etc. Okay. Again, we're going to focus on inland only or inland international rules, and I'm going to highlight the international only rules. And there's really only 3 rules that we're going to have concerns with. Now, again, I'll make sure I focus on those. I grouped the rules. I grouped the rules into categories to make them a little easier to understand. The first 3 give us some general guidance. 4 through 10 apply anytime when we're underway. These rules apply. 11 through 18 is when I can see you. 19 when I cannot, fog. Those are our highway rules. That's why you drive your car, you drive your truck, you drive any vehicle on the roads. Pretty straightforward. And you're going to see a lot of parallels with them. 20 to 31 tells us who you are by your lights and day shapes. So it tells me your status, so I know how to honor that status depending upon the situation. 32 through 37 are sound signals on how we can communicate. Now everything's done pretty much by radio, but still sound signals are very germane out on the water, and it's important to understand what they mean. 38 simply says there's some exemptions out there for boats, mainly on lights, which really doesn't affect us. And then we're going to talk simply about one of the annexes, which are international or inland rules. Okay. I throw this slide out simply to give you an idea of sizes. Everything in the rules is metric. And normally we're dealing less than 12 meters, 12 to 20, 20 to 50, 50 to 100. Most of the light arrangements and sound equipment will be less than 50 meters, 50 to 100, or greater than 100. So those are our key breakpoints in how the rules are set up. Okay, first rule, international rules. Applies to all vessels upon the high seas and in all waters connected therein, navigable by sea-going vessels. Where would you expect to find international rules? Obviously, out on the high seas, out on the ocean. When they come into the U.S., they come into Duluth, Green Bay, Milwaukee. As long as they're in compliant with international rules, they are considered in compliant with U.S. So if I ask you where international rules affects vessels upon the high seas. Inland rules deal with everything inside the coal-regs line. Great Lakes, any small river, lake, stream, Mississippi River, these rules apply. And in Canadian waters, such as Lake of the Woods, Lake Erie, if there is no conflict with Canadian law. So the key thing is there's no conflict, as long as we're in compliance with their rules as well. Okay, Rule 2 is very, very, very important. This is where people can get in trouble very quickly, and it's important that everybody understand it. Nothing in these rules shall exonerate any vessel, owner, master, or crew from the consequence of any neglect to comply with these rules. So basically, if somebody is not in compliant, it's considered negligence. And I'll give you a good example. Say you guys have a company, and Chris, you're the manager, and you got 4 other boats out there with 4 other captains. If you know those captains are not in compliant with parts of the rules and there's an accident, it's not just them that's at fault and can be prosecuted, but it's you as well, because you happen to be the owner or master. If you're aware of a violation going on and don't take actions to correct it, that puts you at fault. So it's a very all-encompassing rule. Or the neglect of any precaution which may be required by your ordinary practices of a seafarer. Again, if it's common sense, people don't do it, you do it, something happens, they will consider that you were negligent of the situation. Now, special circumstances. What special circumstances normally will come in is when more than 2 vessels meet. All the rules are going to address 2 vessels meeting. What if there's 3? What if there's 4? Then we have special circumstances, which simply says, you guys are big boys, figure it out. As long as you don't run into each other, as long as you use common sense, figure it out. Okay. Again, we're going to apply with due regard to all navigational dangers and collisions. That's why we have rules. Special circumstances we just talked about. Again, now, when can we depart from the rules? We depart from the rules necessary to avoid immediate danger. There is going to be an accident. The other guy, the other gal has no idea what they're doing, and you're going to have it. They're not taking corrective action. You shall take whatever action you can, including departing from the rules, to avoid that accident, that immediate danger. So it's basically our escape clause. If everything's coming together and it's going to happen, you may have seen the video I have online with 2 boats colliding. It becomes very obvious. But again, they should have taken an action. Even the stand-on vessel should have taken an action. Okay. Definitions. If it floats, it's a boat. The only exception is that there are houseboats that are permanently anchored. The Supreme Court has found that those, because they're not means of transportation, do not fall under the rules. But anything else that's out there, if it floats, it's got moving people one way or another doing something, it's a boat. It must comply with these rules. Power driven, the engine. No matter how it's propelled by mechanical means, it's a power-driven vessel. Your main Cadle electric motor on your canoe, power-driven vessel. Sail vessels. When we use the word sail, the sails are up. There is no motor running. If the motor is being used, then it's not a sailboat. It's a power-driven vessel. A lot of sailors will motor sail. There's a lot of advantages to it. When that happens, they are considered to be a power-driven vessel and not a sailboat. There's some confusion about vessels engaged in fishing. They're engaged in fishing because their lines, nets, trawls, or other fishing apparatus restricts their ability to maneuver and comply with the rules, which is going to differ from one other one I'm going to talk about mainly. Trolling is not construed as fishing by the definition because it's not commercial fishing, again, with lines, nets, etc. So if a vessel is classified as a fishing vessel, it means its gear is restricting its ability to comply with the rules. Seaplane lands on water. Not under command means the boat is broke due to some exceptional circumstances. It's not able to comply and maneuver according to the rules. Running out of fuel, loss of prop, rudders jammed, any of those things in which it makes the vessel unable to comply, it can claim the status of not under command. Restricted ability to maneuver by the nature of her work. Very different than fishing. These are workboats that are out on the water. I consider them the highway crew of filling up potholes right now. They're restricted. They're not going to get out of your way. Why? By the nature of her work. Examples are dredging, surveying, divers down, transferring people and cargo underway. Up at Sault Ste. Marie, when the boats come through there, there's a service. They'll shuttle out people. They'll shuttle out mail, supplies. Those are boats that are doing work, and they're restricted by the nature of their work. Again, the big difference between by the nature of their work and fishing is fishing vessels, their gear restricts them. The other vessel restricted ability to maneuver is by the nature of their work. A big difference with those two. Sometimes it gets a little confusing. In sight of another, if I can see with my eyes, we're in sight of each other. Very important, because there's a set of rules, 11 through 18 says, if I can see you, these apply. If I cannot see you, they don't apply. And the reason for that is, if I don't see you, I have no idea who you are or which way you're going. Therefore, how am I going to apply these rules? And we'll see those in a little bit. Restricted visibility, anything that restricts my ability to see you with my eyes. Sandstorms, heavy rain, mist, snow, fog, anything that's out there that restricts my ability to see you and therefore apply the rules is considered restricted visibility. Darkness is not. Why? I can see your boat lights. If I see your boat lights, I know who you are and which way you're going. Underway is very, very important because all the rules but one will simply state when underway. Underway means we're floating free, not anchored, not moored, not aground. If you're floating free, the last line leaves the boat at the dock, guess what? You are underway. It must comply with all the rules. If you're out drifting, you are underway. You are not making way. Making way only comes up once in all the rules. Again, please keep that in mind, very important. Our first international rule And if you see a question, it says inland rules only, and you see vessels constrained by draft, they don't exist. They only exist on international waters, seaward of the co-regs line. And basically, they're big boats, heavily loaded, and when they're coming in on any channel system, they have to stay within the channel, and therefore they are restricted by their draft. Once they get over the co-regs line into inland waters, they're just a big boat. International only. Okay, those are our definitions. Kind of gives you a basis from which we're going to work off of. Any questions on that? Pretty straightforward. Okay. Rule 4 through 10 apply at any condition of visibility. Day, night, restricted, it does not make any difference. When that line leaves the dock and you're floating free, these rules apply. Okay, a lookout. You start your car, you put it in gear. Hopefully you got a lookout to make sure that no one's around as you drive in your car. There are no risks. Same thing on a boat. By all means, by sight and hearing, as well as by all available means appropriate for the circumstance. If you have radar, for example, most people don't. You need to make a full appraisal, determine if there's risk and collision. So again, sight and hearing, when, at all times, full appraisal. If I ask you, when do you have a lookout? At all times. Say speed. So we have our lookout, making sure that there's not a risk of collision out there. We know what's going on, full appraisal. And if we see a situation, then how fast can we drive? Good question. It comes up a lot of times. Every vessel should at all times again proceed what? At safe speed, so they can do one of two things. Take a proper and effective action to avoid a collision, or by stopping within a distance appropriate for the prevailing circumstances. Same thing on the highway. Where our safe speed should be where should something happen in front of us, we can either take an appropriate action to get out of the way or stop. That is what is defined as safe speed. So what are the conditions? Visibility. Is it bluebird day or is it pretty foggy out there? Traffic density. Middle of September, no one's on the water, or is it 4th of July where everybody's on the water? Maneuverability. Remember, you're in a 100-foot boat. These things don't stop and turn like a 18-footer does. Background lights coming into a city like Chicago. The state of the wind, sea, and currents. And when I talk to my pro fishermen, they'll tell me, yeah, we were doing 60 over 4-footers to get back for weigh-in. Obviously, the state of the wind, sea, and current has a major impact on what is construed as safe speed. Navigational hazards, springs here, flooding, brings everything down. Visibility, traffic density, maneuverability, state of the wind, sea, and current are all very critical to determine safe speed. And safe speed is so I can do one of two things, either stop or avoid it. And when do I do that? At all times. Okay, so we got our lookout. We're driving at safe speed. How do I know if there's a risk? On the water, it's basically, again, using all available means appropriate. If you have radar, you're supposed to be using it to determine if a risk does exist. If there's any doubt, we assume there is and act accordingly. So basically, if the bearing of an approaching vessel does not change, but the range is decreasing, that is construed as a risk of collision. If the bearing stays the same and the range does not change, they're going parallel. If the bearing stays the same and the range is increasing, they're going away from us. So I have my lookout, I have my safe speed, and I determine if there's a risk of collision. Okay, there's a risk of collision. So what are we going to do? We're going to take an action. It shall be positive, made in ample time, and due regard to observing good seamanship. You will notice The rules don't tell you what to do. It gives you a criteria in which they expect you to comply with. So these are their criteria where you as an experienced captain need to make that decision. Positive, ample time, good seamanship. If we take an action such as altering course or speed, it's very important that it be large and apparent to the other vessels. You want to make sure they know what we're doing, so they see us and they understand how we're responding to that situation. Again, large and apparent. Altering course alone a lot of times is all we have to do, as long as it avoids close quarter situations, made in good time. Again, is large and apparent and doesn't put us into a close quarter situation with another vessel. Again, careful, continue to observe what's going on. And finally, if we need a little more time, what do? We'll slacken our speed. I don't like taking all the way off, because if you don't have water over the rudder, it's pretty hard to take a corrective action. So Rule 8 says if we're going to have, we have a risk of collision, it's going to be early, substantial, positive. It's going to be large and apparent. We keep watching, and if we need more time, we simply slacken our speed, we slow down, so we can assess the situation. So, what side of the road do we run on? We drive on the right side, at least here. What side of the river do we go on, or fairway? On the right or starboard side, as is safe and practical. Again, meeting another vessel head on, we go to starboard, pass port to port. No different than we do with our cars. Yes, I know we drive down the middle of the road sometimes. We drive down the middle of the river, but what are we obligated? To stay to the starboard side. Okay. Narrow channels. Think the Mississippi. Think of coming out of Green Bay. A number of other situations. I would say that I think the Detroit River, down in that area. Power-driven vessels operating in a narrow channel. Proceeding downbound. So I have a power-driven vessel in a narrow channel proceeding downbound with the following current. This applies to everybody. Basically, it's big boats. Shall have the right-of-way. It's the only boat in the rules that actually has a right-of-way. A right-of-way over what? Any upbound vessels. They shall propose the manner and passage, place of passage, and initiate the signal. Today, it's all by radio. The upbound boat is obligated, because it's coming up against the current, to hold its position to permit safe passage. And again, these big boats don't stop. Downbound, you got 15 barges coming down. That thing ain't stopping for anybody. So again, they have the right of way, provided they give the manner and place of passage for anybody upbound, and initiate the signals. Most of it now is done on channel 13, bridge to bridge. Now, narrow channels, let's think of other narrow channels, not just the big rivers. A vessel less than 20 meters in length or a sailboat shall not impede the passage of a vessel that can only safely navigate within a narrow channel. Basically, they're going to stay out of their way, any which way they can. In particular, vessels engaged in commercial fishing shall not impede the passage. Vessels shall not cross a narrow channel if it's going to impede, again, the passage of a vessel that must stay within it, nor are they going to anchor. So if you're downbound or upbound in a big boat and you see another boat coming across, basically you still have the, I hate to use the word right away, but you have the right of way, because you're not going anyplace. A, you're not stopping. B, you're not turning. You're not going to run out of the ground. The other boat is obligated to take that action. Around a bend, I can't see you. You give a prolong. We'll talk about prolongs here in a little bit. When I finally see you, then we'll do the proper maneuvering. But anytime there's an obstruction and other vessels cannot see around it, it's important to let people know that you're there. And we do that with a prolong. Radar is not going to detect somebody up around a canyon, whatever. So again, it's just letting people know that you're there with a prolong. Rule 10, traffic step zones. These are all out on the coastal areas. They're like 4-lane, 6-lane highways for the big boats. We stay out of them. If we're going to cross them, we cross them at a 90-degree angle after we talk to traffic control. So traffic separation schemes, again, it's the big boats coming into the big harbors, container ships, oil tankers and the like. We don't have any on the Great Lakes. We do have vessel traffic control areas, such as the St. Mary's River and the Detroit River in that area, so that they can control fast and the proper separation of vessels through it. But here, no, this is off of Seattle, LA, Long Beach, Chesapeake Bay, and the like. Okay. That is a quick review of the first 10 rules. Any questions?
I think we're good.
Okay, good. Let's do the second one then. Again, they're pretty straightforward. They're like highway rules, and if you got the highway rules down, you're pretty good with that. Okay. Now, the first set pretty much set a standard for us. Here's how we're going to operate. The next set says how are we going to operate when I see you with my eyes. If I see you with my eyes, these rules apply. Why? Because I got to see you to know who you are, which way you're going. Now, there's 2 rules on sailboats. They're very simple. And you probably bump into 1 or 2 of them. So sailboats are a little different than port-driven vessels. So these are under sail. If 2 sailing vessels approach, those are at risk of collision. Everything we talk about, remember, is a risk of collision. Then the rules apply. One of them shall keep out of the other ways. Okay, that makes sense. If the wind is on different sides of the vessel, the boat, so the wind's hitting the port side or the starboard tack, we call it tacks. But basically, if it's the port or starboard side of the sailboat, the port one gives way to this one on a starboard tack, where the wind's hitting the starboard. It's a figure of it as an administrative rule. Doesn't come into a lot of logic behind it. It goes back a couple millenniums, which we don't care about. So basically, if 2 sailboats are going to have a risk of collision, the wind is hitting them on different sides, the port boat gets out of the starboard boat's way. Now, the next one makes a little bit more sense. If they're on the same tack, basically wind's hitting them on the same side, the one to windward gives way to the one that's leeward. And the reason for that is the one that's upwind has the wind and has far more maneuverability. When it's downwind, its wind can be cut off by the upwind boat and therefore is less maneuverable. So again, the windward boat gives way to the leeward boat when it comes to sailboats. Different tacks, port gives way to starboard. Same tack, be it starboard or port, we don't care. Wind's hitting the same side of both boats. Upwind gets out of the one that's downwind's way. Okay. Now, overtaking. Overtaking is passing, no different than on a highway. The key word here, and I do mean key because a lot of people think of bigger boats overtaking if they got to get out of the way. No. Any vessel overtaking any other shall keep out of the way of the vessel being overtaken. You're out there in your metro, an 18-wheeler comes up behind you. That 18-wheeler has to properly and safely pass you on the highway. That's their obligation. Same thing on the water. Anybody's coming up behind you, sailboat, big boat, little boat, if they're going to pass you, it's their obligation to do it safely. Now, I'm going to put that aside for a second. There's something called Darwin. If they're bigger than you and you can, get out of their way. That's not a rule. That's just survival. So if you got a big boat coming up behind you, you may want to get over to the side and let them pass. The law of mass, if they're bigger than you. Okay, overtaking. How do I know I'm overtaking? I see the stern light. The stern light is 135 degrees. Obviously, you'll see that at night. If you're within that cone, you are considered overtaking, and your obligations, again, are to make sure you pass properly with them. The other thing I always say, if you see your taillights on your truck, you don't see your headlights. Same thing here. You should see the stern light and not the masthead light or the side lights. Again, our obligation is until we are passed and clear. So as we're starting to pass, again, we don't cut them off. We make sure they're all the way passed and clear before we come back in. Any vessel. Okay, port tack, overtaking, windward are all giveaway vessels, and I'll talk about giveaway in just a moment. Okay, so we are overtaking any vessel, head-on, too power-driven, head-on situation, risk of collision. All three of those criteria have to be met. If they are met, then this is the only rule that tells you which way to turn. You shall alter course to starboard and pass port to port. No different than on the highway. Power-driven, risk of collision, head-on situation. What do we see at night? We see both side lights, masthead lights. And of course, during the day, we see a vessel coming at it. We pretty much know what's happening. So we talked about overtaking. We talked about head-on. The one that's left is crossing. So we have the same criteria. Too power-driven, risk of collision. We are going to give way to the one on our starboard side. We give way to the boat on our right. And avoid crossing ahead of the other vessel. So we're out there, we're trucking along, and I kind of keep a watch on my starboard side, and I see a vessel coming up on it. And I pretty much have a decreasing bearing, constant range. I know I have a risk of collision. And Rule 8 says I'm going to take an action. I can either turn and go around behind them, or I can slack my speed and let them go ahead of me. But what I'm not going to do is turn on the engine full speed ahead and try to cross in front of them. Again, we give way to our right, we give way to our starboard side. You're out drifting. You're out having lunch, doing whatever. And a vessel approaches you on your starboard side. Who is give way? You are. Because remember, the law says you're underway. It didn't say making way. If you're underway, these rules apply. So you got two power-driven vessels. Both of these are underway, and you have one approaching you on your starboard side. By rule, you're obligated to get out of the way. Hopefully common sense prevails, etc., but don't assume that. That's what the law says, is that you're the one that has to get out of the way. So again, this is schematic, gives you an idea between overtaking and crossing. We give way to the right. Okay, so we have overtaking, crossing, and head-on. And we had talked about giveaway boats. What giveaway vessels simply do is get out of the way, and if all possible, avoid crossing ahead of the other vessel. They can show it. We can turn parallel with them. We can go behind them. We can stop, slow down, whatever. But we don't want to cross in front of them. Now, a stand-on vessel has a lot more obligations. In fact, it's got 3 of them. You're underway and you're cruising down the river, and a 150 passenger party boat is coming up behind you. What is your first action? Well, your first action is to maintain course and speed so that they know how to pass you. You don't get out of their way, etc. The law says you are the vessel that stand on. Your obligation is to maintain course and speed. However, if it becomes rather apparent they are not taking a corrective action to avoid a collision, you may take an action when it becomes apparent they're about ready to run you over. You shall take an action, again, to avoid a collision. Remember Rule 2. So I shall maintain course and speed. I may take an action when it becomes apparent they're not. I shall take an action when their actions alone will not avoid a collision. So again, shall, may, shall. First thing we always do is we maintain course and speed. Then we decide from there if it's going to no accident, fine. If there's going to be one, we're going to take an action. One rule, gentleman is quoted saying, Rule 17 is the last thing you're going to do before you have an accident. So basically, it's if something's going to happen, you get the heck out of the way. Okay, staying on vessels. Shall maintain course and speed. Sounds like I'm overkilling this a little bit, but boy, I've had a lot of people really mess up on this on exams and that because they assume they have to take an action right away. No, you shall maintain course and speed. You may take that action when it becomes apparent. If I ask you, when may you? When it becomes apparent. When shall you? When the other vessel is so close, their actions alone will not avoid a collision. Okay, so you have a big boat overtaking you. Your first action, maintain course and speed. Okay, now we have in the front end, we talked about some definitions. Not under command, restricted, constraint, fishing, and sailing. And I also mentioned that a lot of this applies when I can see you. Well, Rule 18 addresses how we treat each of these boats in open water, not in restricted channel. So if I'm in open water and I can see you, this priority applies. If it's in restricted visibility and I cannot see you, there is no stand on or give way. There is no stand on or give way in restricted visibility. Why? I have no idea who you are. Only when I see you does that apply. Okay, not under command is our #1 boat. It can't comply because it's not under power. The Norwegian cruise line that's floating around right now, it's not under command in more ways than one. The vessel is restricted in ability to maneuver. Why? The nature of her work. Third one down is constraint by draft. International rules only. Does not apply in inland. Engage in fishing or trawling, not trolling. Sail. Sails are up, no motor running. Then we run into power driven, the vast majority of us, underway. Seaplane on the water, about to land. So that is your open water priorities. Anybody above you, you stay out of their way. Under power driven, when we get into that, we're going to be talking about towboats and pilots and a couple other vessels that are all considered power driven. So again, by the lights and day shapes, they're going to tell me what these vessels are so I can know that I have to avoid getting in front of them or around them. The mnemonic we use is new, reels, catch, fish, so, purchase, some. And some, of course, being seaplanes. It's good. And again, we're going to go back here in a couple minutes, and I want to hang lights and day shapes on each one of these. And that, again, that's how we know that what the difference is. Fog, restricted visibility. One rule, it's rather interesting. Applies to all vessels in sight, not inside of another, when near or in restricted visibility. And again, you notice it says to all vessels. Okay, now, if you have radar, there's a whole nother set of regulations. Most people don't, and if they do, they have no idea how to use it. Therefore, mainly that applies to the bigger boats with trained people on them. Every vessel shall proceed at safe speed for the prevailing circumstances. Makes sense. Have your engines engaged for immediate maneuvering. Again, if you have you hear something forward of the beam and you cannot avoid a close quarter situation, or you're not quite sure what's going on, you shall reduce your speed to a minimum, which is bare steerage. So this is the time, it's the only time you really go to bare steerage, is when you're at that point where I got to know where you are, who you are, an idea of how we're going to meet, so that I can just steer out of the way. Once, if I do see you out of the fog, then I apply the other rules. If I don't, we pass the night, as they say, and I'm just down at bare steerage until I'm pretty comfortable we're no longer on a risk of collision. I don't like taking all the way off, because if there's no water over the rudder, the boat does not turn. Okay. These rules apply when inside of another. Sailboats, if they're on different tacks, port gives way. If the wind is hitting the starboard and one's hitting the port, that's all you have to remember. Port gives way to starboard. If they're on the same tack, windward gives way to leeward. Or driven. Any vessel overtaking always gives way. Head on, no one. You stand on. Who's stand on in a head-on situation? No one. We go to starboard and pass port to port. Crossing. We give way to the starboard. So the vessel to our starboard side, you stand on. We're give way. Give way stays out of the way. Stand on shall maintain course and speed, but may, when it's apparent, or shall take an action if needed to avoid a accident. Our new rules catch fish, which we're going to go back to shortly. Restricted visibility, bare steerage, proceed with caution. Again, remember, open water priority. Only if I can see you with my eyes. If I can't see you, I have no idea what your status is. I do not have any idea who's stand on or who's give way. So neither vessel is give way or stand on in restricted visibility. Any questions on that set of rules? Are you okay with them?
Yep.
Good. What I want to do is I'm going to go through the next two, and then we're going to take a little bit of break, and then I'm going to go through navigation, and I want to show you, I have another camera set up, and I'm going to show you plotting in case you don't have it down. I'm going to go through and plot a couple problems out.
Okay.
So that first set of rules tells us how we're driving our boat, how we're driving our truck, whatever. The next set is going to be lights and day shapes to find out who you are, how big you are, and which way you're going, and then your status in open water. So it's going to give us information I need so I can comply what we just talked about. And again, when you divide the rules this way, I think it makes it a little bit more understandable of what we're looking at and why. Okay, when are lights required? Everybody will say, well, sunset to sunrise, which is true. Or sunrise to sunset in restricted visibility, just like when we drive with our lights on in our car, or when you feel the circumstances warrant it. Again, it's no different than on our vehicles. Now we have side lights, masthead lights, and stern light. Masthead is always white, 225 degrees facing forward. Oh, go back up. So it's white, 225 degrees, always face forward. That's the definition of a masthead. It's not an all-around. Side lights, now we have red on our port and green on our starboard. Let me go back to it again. Why do we call them side lights? Because not everything has what we construe as a bow light. The rules define them as side lights because sometimes they're way back up in a superstructure someplace, especially on bigger boats. So that's why we use the word side lights instead of a bow light. Stern light, we talked about, it's on the back, faces backwards, 135 degrees over the horizon. If you see the stern light, you don't see the masthead or side lights. That tells you that you're in an overtaking situation. Tow light, we'll talk about that more in a moment, is yellow. Any light on the boat that's yellow has to do with towing. And all around 360. On our smaller boats, we combine the masthead light and the stern light into a 360 degree light. Okay, here's our lights. Our masthead facing forward, 225. Port and starboard, red and green, are half of that. Off the stern, we have our stern light, 135, and right above that, we have our towing light, which is also 135. The difference is one is white and one is yellow. Special flash in yellow. You'll see those on Mississippi and other waters. When there's a big raft coming up, they're supposed to at night have a flash in yellow in the front saying big boat, and this is the front of a barge. Now, I'm going to start with what I consider standard light configuration. Standard configuration is what most of the boats will have, and to that, we're simply going to add a couple more lights. So we're going to go through our new reels catch fish. This is also in the back of your book. I think it's on page 23. There's a little box there with new reels catch fish. And off of that will be obviously the vessel name, the lights, and the day shape and the sound signals. It basically is going to encompass the vast majority of what I'm going to cover now. Standard configuration, again, under 50 meters. Side lights, masthead, stern. I don't care if your boat's 12 feet long, you can run these lights. We do a lot of exceptions. Your smaller boats are exceptions. That's why I don't even like to talk about them. As far as rules go, we're talking big boats. Under 50 meters, side lights, mast, and stern. And there you be, side lights, mast, and stern. Boats less than 12 meters can combine them. That's why most people think, well, I don't have a masthead light. Well, you do. It's really, you're all around. Okay. Now, first big change, 50 meters or longer, we'll add a second masthead light, abaft and higher, basically by the stern. When they talk about abaft, they're talking the back of the boat, by the stern and higher. So basically it's saying the boat's going that way. Why not abaft and lower? Well, you never see it. All I would do is see the one front masthead light, and it would not tell me a lot. I wanted it higher so that A, I can see it, and it gives me a direction of travel. Less than 50, 1. Greater than 50, 2. And that goes up to our 1,000 floaters. There's only 2 masthead lights. Here's an example. Abaft and higher is the second masthead. And there are your side lights. They're back up in the superstructure. Okay. Towing is a power-driven vessel. They are extremely dangerous, and they have no special status. They're construed as a power-driven vessel. So when you look at your questions in that, if it's talking about a towboat is a power-driven vessel, no special statuses in open water priority. Stern tow, hip tow, pushing ahead. 3 different ways. Now, there's a big difference between inland and international rules when it comes to towing on the hip and in front. However, when we tow astern, they're the same. Now, anything that deals with towing always has two masthead lights in a vertical line. That's a gimme. It always has two mastheads in a vertical line if it's towing. Side lights, and now we have our stern light, but above the stern light, we have a towing light. So we've added two lights to this configuration. We add a third masthead when we drop the rig back more than 200 meters and our first day shape, which is the diamond. So we took our standard configuration, we added one masthead light, we added a tow light above the stern that says we're towing astern. And when we go way back, we add a third light for the diamond. The way I always explain it is power driven, towing, big tow. First masthead says we're power driven, second one says we're towing, third one says that we're a big tow, it's back to 200 meters. Yellow over white, we're not alone tonight. When I see yellow over white, and the reason is that configuration is saying there's something back here. You have to find what is back here and how many of them are there. Inland, international, it's the same thing because the danger is real on both sets of waters. So yellow over white, towing tonight, something's back here. We want to find out where it is. Inland, international. The object being towed has side lights and stern. It does not have a masthead light. Why? It's not powered. Sailboats, not under command, and a vessel being towed do not have mast lights. Why? They're not powered. Each boat in the tow must be lit. We don't want the tug and then the last one being lit because we have no idea how many other boats are there, and we may have the illusion that we can cut between them, which we can't. So every vessel in the tow must be lit. Side lights and stern. Again, inland, international, there's no change. It's the same configuration because we have to warn people what is behind us. Now the big change is on pushing ahead around the hip. Inland, we have turned the stern light off and added two yellows. Yellow over yellow, I'm a pushy fellow. We still get our side lights and we still have our double masthead because we're towing. No stern light. Yeah. On the object being towed on the hip or in front, we have our side lights astern, but we added the special flashing. So basically it's warning people coming down the river that there's a big barge here in front and don't try to go between the two lights. So again, what we've added now is we've added three yellows, two on the tug, one on the barge. Obviously, when we push the barge in the head, the one that's right and directly in front of the tug will not have a stern light. It serves no purpose, plus it may end up blinding the pilot as well. Okay. Go down to, okay, now international on the hip or pushing the head, we've only added one light, a masthead light. Remember, I keep saying, if you're towing, there's got to be two masthead lights in a vertical line. Here we have our side lights and a stern light. There are no towing lights. International. So the big difference between inland and international are the number of yellow lights. Pushing ahead on the hip. International, all we've done is added the second masthead light. However, when we get inside the coal rigs line, we add three of them. One in the barge, two in the back of the tug itself. So in international towing, there is only one yellow, and that's when towing the stern. Good example. Again, international If I asked you, you just crossed from international to inland waters and you're a stern tow, what are you going to change? The answer is nothing. If I asked you the same question on pushing ahead, you're going to add the 3 yellows. And of course, there's always got to be an exception someplace. Huey P. Long Bridge. Anything north of the Huey P. Long Bridge in New Orleans on the Mississippi, they're not required to have a mast headlights. Low bridges. This goes back, 80, 100 years ago. So again, any tugboats on the Mississippi will not have a mast headlight. So here's all your lights. One masthead says power, second one says tow, third one says big tow. There's your diamond, there's your side lights, and on the stern are the 3 lights, a stern light, and then the 2 yellows. So those are lights that are being changed depending upon their status. Okay. Sailboats. Pretty straightforward. They do not have a masthead light because they're not powered by an engine. Side lights and stern with the optional red over green at the top, red over green sailing machine. If the motor is running, then they turn off the red over green and they turn on a steamer light, which is what they call a masthead light. So if they're motoring, they're a power-driven vessel, side lights, mast, and stern. If they're sailing, then all they're doing is turning off the masthead and adding the optional red over green. They do not have a day shape. You're out in your kayak, you're out in your canoe, you're out there paddling around in a boat or oaring. You're obligated to have lights. If you can't have the standard light configuration, you shall have a electric torch or lit lantern, basically a flashlight, to be shown in sufficient times. Boy, I've talked to a number of kayakers out there, and midday, and you talk to them, and no, they don't have lights, they don't have any whistles. Bad news. Plus, it's also illegal. You always have to have some type of luminance because you could run into a situation where that's going to save you from getting run over by another boat. So they are obligated to carry them, especially at dusk. I've seen enough of them out there, you darn near hit them because they have no lights and you just don't see them there. Okay. Fishing, commercial fishing. And these are, again, remember, their gear restricts their ability to maneuver, comply with the rules, and therefore, because of their gear, we call them fishing or trawling. So if it's a fishing vessel, there's one of the old Lake Michigan, Lake Superior, they will have red over white. So they have 2 all-arounds at the top, red one being the top one, yellow one, white one being the lower one, yellow or white, lines are in sight, side lights and stern. Their day shape will be the cone apex to apex. Trawling, now when you trawl, you got to move. You got to keep moving. You got dredges, nets, you're out there tripping, whatever. And therefore, I want to let everybody know that I'm moving. Well, green means go, red means stop. So it's going to be green over white saying, hey, I'm moving. Please understand that and stay out of my way. Day shape is the same, 2 cones, apex to apex. Red over green, again, red over white, nets are in sight. Red over white, lines are in sight. Green over white, nets are in sight. We'll get it right yet. Okay, again, fishing boats, commercial fishing is restricted by their gear. Constraint by draft, our international only boat does not exist in inland waters. If it wants to claim that status of a constraint, it may display where best can be seen 3 all-around red lights, rudders, rubbing rocks. The day shape is a cylinder. Once it gets into over the coal rigs line, it's simply a big boat and it cannot claim that status. The difference between inland and near coastal. If there's a question and it says inland only, and it's got the word constraint by draft crossed it out, it means nothing. Restricted inability to maneuver. By what? The nature of their work. Okay, they're doing work on the water, divers down, transferring people, cargo, dredging. They display 3 lights: red, white, red. Red, white, red over a working man's head. The day shape is ball, diamond, ball. So I got red, white, red, red, white, red, ball, diamond, ball. These babies are not moving for anybody. They're out doing the work. Stay out of their way. If they're having a dredge operation going and they don't want you to go on one side, they're going to display 2 red lights. Again, red means stop. 2 balls. On the side they want you to pass will be 2 green lights or 2 diamonds. Green means go, red means stop. Not under command, the boat is broke. Basically cannot comply with the regulations. Run out of fuel, fuel filters plugged, rudders jammed, lines in, something happened to the props, whatever. They're no longer able to maneuver. So what we have are our 2 red lights and 2 balls. Red over red, captain's dead, his balls are in the rigging. The #1 boat that's out there. Now, a couple other poor driven ones. Pilot, upper one white, lower one red. White over red, the pilot's making red. These are, the boat itself is nothing more than a taxi cab. It's taken out a very experienced captain out to another vessel to help either bring the boat in or take the boat out. If anybody's been on a cruise, these are all foreign vessels, and by U.S. law, they must have a pilot on board. You will always see with the cruise ship going out or coming in, you will see a pilot boat associated with it, either dropping off or picking up the other captain of it. No special privileges, it's just to be recognized. Okay, not underway. Now, all this we've been talking about is you're not anchored, moored, or ground. So what happens if you are anchored, moored, or aground? We're not underway, no one's on the boat. How do we make sure people know what's happening? Vessel not underway, less than 50 meters, we're back to our 50 meters again. We'll have a single all-around white light, our anchor light, and the day shape is a ball for any size vessel. So no side lights, no masthead lights, no stern light, it's simply one all around. At 50 meters or more, we add a second all around. These are not masthead lights, these are all arounds. The second one is abaft, again, by the stern, and lower. It's lower than the front one. At 100, we add deck lights. You have a very big boat here, and a light on the front and a light on the back is not going to do it. So we have to, again, illuminate the deck so we know there's a boat there. So here's a vessel that was up out of Duluth. You can see the front masthead light and, front all around, and at the stern you see the other all around, which is obviously abaft and lower, and then you see the deck lights. So less than 50, 1 anchor light. 50 to 100, 2 anchor lights. 100 and more, 2 anchor lights plus deck lights. Ground. Ground, in essence, is we're anchored to the ground. So we'll have our appropriate anchor lights on for the size of the vessel. To that, we are going to add once more two red lights, excuse me, and 3 balls. 2 from not under command, 1 from an anchor, make 3. Don't confuse this with constraint by draft, which has the 3 red lights. That day shape is cylinder. Here, a ground is 3 black balls, and we have the 2 red lights where best can be seen. Plus, they are appropriate anchor lights. Vessels less than 23 feet at anchor, not out in any area that they can get run over, not required to have lights or day shapes. Vessels less than 12 meters aground, doesn't have to have the shapes. Vessels less than 20 meters and anchored in a special anchorage area designated by the Secretary are not required lights or day shapes. There are 1 up at Fish Creek, there's 2 of them in Sturgeon Bay, there's 1 in Oshkosh, and then there's 2 or 3 of them in Milwaukee. Those are the ones that I'm aware around here. Again, they're designated as special anchorage areas by lat long. Boats can go on there, anchor, no lights, no sounds, everybody's gone home. Okay, that is our lights and shapes. Again, we start with our standard configuration, and to that, we're going to add either another masthead light or special lights where best can be seen. One that I didn't cover here, I think it's covered later on, but just as important, is public service. Public service is flashing red and yellow, and it has no special privileges. It's simply so that it can be seen. The harbor master in particular, very common. I equate it to the mall cop. He's driving around the parking lot helping people out. He's got flashing lights, yellow and red possibly. No special privileges, simply so that they can be found on it. Questions?
Nope.
Okay, good. I mean, if you guys got this down, and like I say, from page 23 and on in the back of the rules book, you're going to do good. And again, I'm just trying to clarify things, make sure that again, there's no misunderstanding. I'm going to do the last one, and then we're going to take a break, and then we're going to come back, and I want to go through navigation.
Okay. I guess just with these rules, is it all about knowing them, like memorizing them, or is it like, are the questions going to be gotchas, or is it going to be simple stuff?
It's going to be simple stuff. Off in the horizon, you see, 2 red lights. This is a boat that's not our command. The key thing is to read the question. I try to add a little narrative to them, otherwise they get pretty boring. But you just cross the co-rigs line, towing astern, and your first mate asks you what you should change. The answer is nothing, because the lights are the same for inland versus near coastal.
Okay.
I've gone through the Coast Guard exams, the old ones that they've had. They're changing them now, and they got 23,000 questions, and I've gone through about 2,000 of them or so are on rules, and they can be pretty hideous. But the big thing is you cross out everything that's not germane, and they'll have a question that's really about 3 words long, and that's the one that you answer. But there's so much garbage in there that people don't take the time to really figure out what they're asking. And that's what I always say on my exams too. Please make sure you know exactly what I'm asking. Your tugboat is going out to pick up a tow. What lights? Well, standard configuration, side lights, mast and stern, because it's not towing yet, right? If it starts towing, then we're going to add the tow lights. We're going to add a second masthead, and we're going to throw that towing light over the stern light, because we're towing a stern. So again, what is your status? What am I doing? and then let the lights reflect that. If you do it that way, it's really simple. The interesting, along with talking about exams, they'll go through and I'll have a guy get 6 wrong, and we'll go through the answers, and he'll say, well, that's not the right answer. And I said, why did you put it down? He'll look at me square in the eyes and say, I don't know. You have no idea how many times I have heard that. And I just roll my eyes. It's like when you go through these and you're done, especially in the rules, you go back, you read the question and only the answer you picked. I see guys circle B and put down A. Those are the mistakes you want to avoid. And it's really important to take your time, go through it, check it, and make sure you don't make those mistakes. Okay, the last one is sound signals. I know my first group, we talked about how we drive the truck, how we drive the boat. And that next set of rules said, how do I know who you are? And that's the lights and day shapes. You're going that way, you're that kind of a boat because that's the day shape you're showing me. The last part here deals with sound signals. How do we communicate? Up until a few years ago, it was with whistles. Now everything's done by radio. Okay, whistle, basically a whistle, horn, whatever you want to call it, makes a blast as specified in Annex 3. A short is 1 second long. A prolong is 4 to 6 seconds long. 4 to 6 seconds. Not 3 to 5, not 5 to 7, 4 to 6. Okay, now here we're going back to our sizes. A vessel less than 12 meters shall have an effective sound-making device. I don't care if it's your horn, a canned horn, whistle, whatever. What do we call it? An effective sound-making device. From 12 to 20, we have a whistle. From 20 on, we have a whistle and a bell. So effective sound-making device, whistle, whistle, bell, and at 100, we add a gong. So again, depend upon the boat. So what do we have between 20 and, between 20 on up, what do we have? Whistle, bell, and a gong at 100. Okay. Inside of another, 2 power-driven vessels, underway. You know, it does not say making way. In a meeting or crossing situation. 1 short, I'm leaving you on my port. 1 short, my port. Just remember that, and everything else is there. 2, I'm leaving you on my starboard. Now the key here is where I'm putting you. It's my boat, not your boat. So if I see you and I give you 1 short, you know that I'm going to leave you on my port side of the boat. If you're in agreement, you're going to respond with the same. 3, stern propulsion. Stern propulsion can be a couple different things. Backing out of a dock. Again, remember we're in a 100-footer. I'm coming up on a bridge and with a following current. I put the boat in stern propulsion so I don't run into the bridge. 3 shorts. Upon hearing 1 or 2, again, we respond in agreement. 5, they used to call it danger doubt. Now they just call it danger. You're going into danger. You're causing a dangerous situation. Think of somebody backing up into your truck in a parking lot. What are you going to do? You're hammering that horn. 5 or more shorts. Danger. You're going into danger. If I want to get somebody's attention because they're causing a dangerous situation, they're not looking at me as they're coming at me, I'm going to give them 5 shorts or more. I want them to look at me. I don't care if they understand the signals or not. It's unimportant. If they look at me, we can negotiate. 1, my port. 2, starboard. 3, stern propulsion. 5, danger. Now, overtaking is written differently, but it's the same thing. One short, I intend to overtake you on your starboard. Well, if I'm overtaking you on your starboard, what side of my boat am I showing you? My port. I'm overtaking you on your port. What are you seeing? My starboard. Nothing's changed. Okay, let's go back to that one. When you read the questions, gentlemen, am I saying you're overtaking her on her port, or are you overtaking her on your port? Read the question. Two different answers. Always remember, one short, I'm showing my port. I don't care how I'm showing it to you, but I'm showing you my port. It's one short. Can't go wrong. Now, international, it reads differently, but it basically is the same thing. One short, I'm altering my course to starboard, but what am I doing? I'm showing you my port. I'm altering my course to port. What I'm showing you, my starboard, two shorts. Stern propulsion is 3. Okay. Now, this is the third international rule that you want to make sure that you understand. There are 3 of them that are important. Overtaking, international rules area, narrow channel. I'm going to start out with 2 prolongs, followed by 1 or 2. I intend to overtake you on your starboard. I'm showing you my port side, right? 2 prolongs followed by 1 short. Same thing, I'm overtaking you on your port. I'm going to show you my starboard, 2 prolongs followed by 2 shorts. So the 1 and 2 shorts are the same, but it's prefaced with 2 prolongs. This is the other part of that that's different. When in inland, if I gave you a 1 or 2, you respond it with a 1 or 2. Here, your response is a prolong, short, prolong, short. Off in the distance, I hear a prolong, short, prolong, short. What just happened? Somebody disagreed in an overtaking situation, right? If I hear somebody off in the distance, 2 prolongs and 2 shorts, they want to pass that other vessel on their starboard side. You're going to show them your starboard side when you're overtaking them. So that's the big difference. That's the third international rule that's different. Please don't forget the prolong, short, prolong, short. Around the bend, the prolong, I can't see you. Leaving a dock, inland only, prolong, I can't see you. Now, in or near fog restricted area. I have it broken down in a very simple way. And I mean, it is very simple. You can take all these rules and break them down. And in the back of the book, I'm sure you saw it where I do 1, 2, 3, 4, 5. 1 signal, 2, 3, 4, 5 signals. So 1 signal, 1 prolong is a power-driven vessel doing what? Moving. They're making way. 2 prolongs, power-driven vessel, not moving. 2 words, 2 sounds. You have no idea how many people get that mixed up. It's very simple. Moving, not moving. 1 prolong is moving, 2 prolongs is not moving by propulsion. If you're out there drifting, what are you doing? 2 prolongs, just not making way. You have no propulsion, you're just drifting. 1 or 2. All power-driven vessels will either do a 1 prolong if they're moving or 2 prolongs if they're not moving. Prolong and 2 shorts, 3 sounds. It includes all boats with a special flashing or special light. If it's more than your standard configuration, Not under command, 2 reds. Restricted, red, white, red. Draft, 3 reds. Fishing, red over white or green over white. Sailing, red over green. Towing, yellow. All of them have a special light, correct? Therefore, they are prolong in 2. All my special boats. Cannot go wrong with that. Prolong in 3, 4 sounds. Manned tow, TOW. So the tug, because it's got the yellow lights, is going to do a prolong in 2. The man towed, provided is the last boat. It's got to be the last one. And if manned, will sound a prolong and 3, MTOW. Last one is our pilot. If they want to be found, they will add 4 shorts to the prolong. Prolong in 4. Pilot. In fact, it spells out pilot. So again, in the fog, restricted visibility, it's 1, 2, 3, 4, 5. Your tugboat is going out to pick up another boat. Standard configuration, side lights, mast, and stern. If it's moving, it's 1 prolong, moving. It stops to pick up that tow. 2 prolongs, not moving. Once the tow is hooked up, I don't care if they're moving or not, it turns on the yellow light. It turns on the yellow light, therefore it's going to sound a prolong and 2. Towboat entering the fog with a tow. What's it going to sound? Prolong and 2. It's not power driven. It is, but it's not that status. It has its status of being towing. Got a yellow light, prolong and 2. Okay, not underway. Just like we had special lights for at anchor, we have sounds as well. Rapid ringing of the bell. So for not underway, which means we're anchored, moored, or ground, usually means we're anchored, not moored, or yeah. So what we're going to do is we're going to ring a bell for 5 seconds. At 100, you notice there is no 50 here. This is the one rule in which we don't have that less than 50, more than 50, 100. It's less than 50, it rings a bell. At, less than 100, it rings the bell. At 100 or more, we add the gong. Big boat, bell, gong. So if it's 75 meters long, what's it going to do? It's going to ring a bell. At 100 meters, it's going to ring a bell and a gong. What if we're at anchored and the boats are still coming at us and they don't hear our bell? Bells are pretty light, especially in the fog. We can sound an optional short, prolong, short. Off in the distance, I hear a short, prolonged, short. Oh, I have a boat out in front of me that's at anchor. I better proceed with caution. Short, prolonged, short. At anchored, restricted visibility. I have the misfortune of running my ship aground. What I'm going to do, and you can see the 3 balls here in the picture, what I'm going to do is I'm going to hit the bell 3 distinct times, then ring the bell, then hit it 3 distinct times. 3 balls, 3 hits to the bell. I'm a dump ship, dump ship, dump ship. I ran my ship aground. So I'm going to do everything that I would normally do for the size of the vessel that I have. But being aground, I'm going to hit that 3 distinctive times so that people know that I am, in fact, aground. Special anchorage areas like we talked about before, no lights, no sounds. Now, a good way of again, handling sounds is if I can see you, it's a short. If I cannot see you, around the bend, leaving the dock, restricted visibility, all starts with that prolong, except for the international overtaking. If I'm at anchor aground, I'm not underway, it always starts with a bell. That divides your 3 groups very quickly. Don't forget the optional short, prolonged, short. Those will show up sooner or later. Okay, Again, I see you starts with a short, restricted, always starts with a prolonged, and anchor always starts with the bell. Less than 12 meters, effective sound making device. 12 to 20, whistle. 20 to 100, whistle and a bell. Greater than 100, whistle, bell, and a gong. Again, here's my little mnemonic for that. Hope use it if you it'll help you. But remember, 2 prolongs is not moving. 1 prolong is moving, power driven. Distress. There are many distress signals. The key ones is any flares, rockets are red. Continuous blowing of a foghorn. I equate that to car alarms. You want to go out there and shoot the car. Continuous blowing of a foghorn is a distress. The orange flag. Now, I would suggest, and we'll talk about that when we talk about the deck. Flag is a $6 flag. You stick it in your tackle box. If you don't have flares or your flares are outdated, that is a visual distress signal for daylight hours. Therefore, you pull that out, and that'll take care of a ticket you may get otherwise. Will anybody know what it means? Absolutely not. Will it keep you from getting a ticket? You bet. So again, they're about $6. I tell everybody carry one. It just, you may actually need it sometime, or again, like I say, it may help getting a ticket for not having flares. Waving the arms, I call it the albatross move. It's not, frantically waving them, it's waving them up and down. And of course, I like my orange smoke. During the daylight hours, people don't respond to flares, they don't respond to flags, and they sure the heck don't respond to waving. Orange smoke, they will. If you have a man overboard or a sinking situation where you really do need help, orange smoke is a good chance of getting it. Okay. Inland only, strobe lights, 50 to 7 flashes a minute is inland distress. Law enforcement, blue, the flashing blue light special. When they want to talk to you, they may display a blue light. I'm not sure if you guys heard, but anybody with blue LEDs on their boat are getting tickets, especially up on the St. Croix. I know when I talked to Paul over there, he said, yep, so they're issuing tickets because only law enforcement may have blue lights. So if you know anybody that's got blue LEDs, you want to make sure they take them off. Public service, I mentioned a little bit earlier. Flashing red and yellow, basically no special privileges. It's the mall cop approach, basically the harbor master in like. If you see somebody coming up behind you, flashing red and yellow lights, what do? You maintain course and speed. Pipeline. Remember we mentioned earlier, if I have 2 red lights by a dredge operation, do not go there. 2 reds, 2 balls. Red, white, red over working man's head, that's the dredge. Pass on this side, the 2 greens. The row of yellows is the pipeline. And this is really, I want to see the oxymoron. 2 sets of red lights go between to get through the pipeline. We have 2 reds on under command, 2 reds aground, 2 reds don't pass on this side, and 2 sets of reds go between to get through the pipeline. And it's just a picture of that type of rig. Diamonds are green for pass on that side. The 2 black balls, red at night. Questions? And we'll do it that way. Okay. Magnetic compasses. Now, I know we got GPS. Everybody uses GPS alike. However, I'm going to come back that as a commercial mariner, it's important that you have a compass on board. Why? GPS does go out, and it does. then you got to have some means of getting them safely back to shore, especially if you're in fog or out in big waters. And there's very simple to use. There's a couple principles we need to understand, and that's what I want to cover. First, the compass points to magnetic north, not to true north. The problem I have is in this area, it's the only place in the world compasses point to true north. That's why Minnesota, Wisconsin, and the UP are hard to, because that's the way they do, and that's the way I learned it until I found out that no, it doesn't work that way in other parts of the country or the world. Okay, compasses, 360 degrees, aligns with magnetic north, with the magnetic fields. The lubber line, which is down the middle of the compass, aligns with the center of the boat, so it tells us what our true boat's heading. Again, we rate everything in degrees, 3 digits, 270057. Always want to keep it in that 3-digit way. When a boat turns, what does not turn? The compass card. It stays aligned with magnetic north. So on charts, if charts are in true degrees, how do we know? We use our compass to use a chart. We have to factor in variation. Variation changes geographically across the country. So the difference between true and magnetic is variation. Again, variation changes geographically. It's written as easterly or westerly. I don't get into correcting or uncorrecting when we go through stuff. Basically, when you do the math on it, we treat them as variables, which we're going to add or subtract. Here's the line. So basically, from where we are right now, our compasses point true north. Once you get away from that, they don't. East Coast can be 15, 16 degrees off. West Coast, especially up towards Alaska, can be as many as 22 degrees off. Why is this important? Every degree of error puts you off 107 feet per mile. You can imagine if you're off by 10 degrees on it, that puts you off 1,000 feet per mile going in the wrong direction. So very quickly, this is how people get lost, especially elk hunting out west. Again, magnetic compasses don't point to true north. They point to magnetic, and what we have is variation. On the boat, we have what is deviation. Deviation is caused by anything electrical, magnetic influences that may be on the boat, including the boat itself. Deviation, again, is the angular difference between magnetic and ship's compass. So here we have a fixed compass. Because it's a fixed compass, we have to make that calculation with it. Deviation also changes with the ship's heading. As the magnetics run through the vessel hull, different angles will change its influences. So compasses, again, per ship's compass, we have to come in and account for both variation and deviation. If we're going to again, steer a chart reading bearing, we have to convert to ship's compass for the helm. If we go the other way, somebody gives us a bearing, and off the compass, we have to convert it to true to put it on a chart. This is there's one other mnemonic that's probably a little bit better. True, variation, magnetic, deviation, compass. When we go from true to compass, we add west. When we go from compass to true, we add east. Just a quick example. So here's our heading, 127 true. We factor in our variation. Where do we get variation? The compass rose. All your charts have a compass rose, and in that compass rose is the variation. So we apply that, we get magnetic. We go to a deviation table. Each boat has its own deviation table, and we apply that, and it gets us our compass. Now we go just the opposite. So now I can drive 127 true and avoid Peshigo Point. The helm is actually steering at 137. So if you're going to steer with a compass, you got to convert. Going the other way, we have our compass. I apply my deviation. It's my magnetic, my variation, and then to true. So 225 per ship's compass is what I see off the compass, and that's our heading. I want to plot it. Apply first my deviation. Here's my compass. Apply my deviation, my magnetic, apply my variation. It gets me to true. So the difference between I see on the compass, which is 225, and what is actually the true course on the chart is 209. Now, two more things and then we're done with compasses. Again, compasses don't point to true north. We got to convert to true if we take a compass reading. And to convert from a compass to true, what do we apply first? Deviation, then variation, which gets us to true. If you want to go the other way, we got to apply variation first and then deviation. Something at times I mentioned compass error. Compass error is what I call our checksum. It tells me if I got a right answer. I take my two variables, variation, deviation, and I apply them. Here I have a 9 and a 4. It gives me 5. The west is larger than the east, so it's 5 east. If I apply 5 east to my compass, I get 265. If I apply 5 west, I get 265. If I apply 5 west to 265, I'm adding, I get the same answer both ways. This is basically all you need to know. Now, in the past, all my plotting problems would be per ship's compass, and you would have to convert them. And this is a little mnemonic that you would use. Now, basically, the Coast Guard and the rest of the world does not use compasses. Everything is GPS or gyro compass. Therefore, everything that you're going to see is going to be true. However, if you're out on a boat and everything goes to pot, you may well have to use a compass, and you do need to know the variation for your area, as well as a little idea what your deviation is on your boat to get back to shore. You're 10 miles off of Madeline Island up in Superior. You can't see shore. You have a choice. Go to Canada, go to Sault Ste. Marie, or come back to where you want to go. You need to know that you got to go south. So how much to the south is your compass pointing? You have to apply your variation, deviation to make sure you're getting back to shore where you want to. So it is important. Deviation tables. We develop, all boats need a deviation table. You're out there with your Ranger, you're out there with your Lund cruising around. You want to know if you can trust that compass. If it's a mounted compass, then you need to determine your deviation. If it's a handheld, you simply step away from everything, take a reading, and it's magnetic, you go right to true. So what we do, and I recommend this on all boats, basically you set your GPS to magnetic, you go in a little menu, you set it to magnetic, and of course we know the difference between magnetic and per ship's compass is deviation. So what we do is we set up our little table here, just like this. So whatever 30 degrees on the boat heading, we're going to look at the GPS set to magnetic, and any differences is caused by deviation. So in this case here, 60, it's 62, so we know we got 2. Because we're going from per ship's compass to magnetic, we're adding 2, so it's got to be 2 east. And then we work our way through the table. In this example, it's going to be probably 4 degrees or less. If you do this and you have less than 4 degrees or thereabouts, you're going to totally ignore it. Why? Because your compass is not that accurate, and the gradations on your compass are not that accurate. But if you know your compass is kind of pretty much pointing to the correct direction, it's great. I had one gentleman do this, north-south, right on, east-west. He said it was off by, I think, like 20 to 30 degrees because he had it between his GPS his depth finder, and his radio. So he knew that if he went in those directions and relied upon his compass, he'd be off about 3,000 feet per mile. So he bought a handheld basically to resolve that. It's something you need to know to be safe on the water. Any questions I may ask you is going to be based on TV NBC. Again, just all you have to remember is that little mnemonic there to be safe on the water. Yeah.
I was wondering if, so like on that map of Long Island that we got,
Yep.
There's a compass rose on there, and then it has the magnetic in the center.
Right.
Do they already have the variation figured out for that area?
Not, yes, but don't use it.
Okay.
Yeah, that's. I wish they would never have that on there. Everything we're going to do is going to be true, and when people start using that, they start making some horrible errors. Everything you're going to have is true given to you, so we always use the outside of the rose. But you're right. Coast Guard Auxiliary teaches that. It's just a bad practice. The other thing is that compass rose is a lot smaller on the inside, and it has a lot more degree of error on it. So, and you bring up a very good situation. When you do your angles, be very careful to make sure you're always using the outer rose, not the inner one. I've seen some pretty bad mistakes with that. Okay. Any other questions on compasses?
No, I think we're good.
Okay. Quick go through on publications. There are a number of publications that are very important to us. Again, remember now, you were commercial mariners. The Coast Pilot is one of them. Anytime you go to a different area, you always want to consult the Coast Pilot. Again, these are downloadable off of NOAA's site. You don't buy them. You download the sections that you want. There's 9 volumes. They contain detailed information in each of the areas. Example would be, again, general information. Chapter 2 is everything to do with regulations, from disposal, fishing regulations, on through. A general overview, and then they will have an area that are very specific. Now, again, they're going to contain just a ton of information, anchorages, channels, currents, not current, obviously, but basically what is on the average that's there, changes in water elevations over time, etc. And everything is arranged by chart number. Years ago, I would say this was your encyclopedia. Today, I'd say it's your Wikipedia. Everybody goes to Wikipedia. Well, that's what this is for an area. Tons of information. How do we use it? We find the area that we want to cover. We're going to use Western Lake Erie. We want to go to the Cleveland area. And we look for the chart. The charts that are covering that area, 14839. And then again, this one that's a little bit smaller. We go through the book and we find the chart numbers we want. So these are the chart numbers that all the information is contained on. We look for the section we want the information, the topic. So we want to find out about safety zones. So this will explain to you all the safety zones in that area, as well as where you get additional information. So again, it provides a lot of information, especially if you're going to go to a totally different area of the country. You're running down to Florida, you're going out to the Carolinas, take a look at them. You find a ton of good information in there that's going to keep you out of trouble. Local notice to mariners. There's a notice to mariners, which is the big one that deals with everything worldwide. For us, we want to look at the local notice to mariners. This is how the Coast Guard is working with you. And basically, the Coast Pilot is updated by that. I'm going to get back down to my next one. So again, it's used to update charts, light lists, Coast Pilot, other navigational publication. If there's a restriction in the area, it's going to be posted in a local notice to mariner. If they're changing buoys, if they're having events and then an area is going to be cordoned off or a bridge closing, it's going to be in the local notice to mariners. So anytime you travel to an area, you guys are going out for fishing tournaments, check on the local notice to mariners. See if there's anything there that you need to know that's going to make sure that you can get to where you want to go. Because there can be things like dredging areas, dredging projects, whatever, they'll be listed in that. You are required by law to have updated charts on board, and the way you update them is through, again, local notice to mariners. So it gives you a lot of information, tells you what's happening currently, it's warning you, and it updates all other publications. If you go out there, and I would suggest you guys do that, just click on it. You go out to navsen.uscg.gov, click on the 9th district, click up the current one, and it'll tell you what buoys are replacing, what buoys got lost, where are the dredging projects, special security zones because of events, all those things. Everybody should be checking it at least probably once a month, ideally. Light list. All those crazy buoys, if I want to find out about those buoys, they're in the light list. It's going to be a complete list of all lights, buoys, day beacons, fog signals. Then each volume, again, is updated through the local notice to mariners. This is what you find in the light list. First, you got the number. The number that you see there is their reference number for that light. This one happens to be a location, 31st Street. It's going to give you a lat long. Sometimes this lat long can be used in your go-tos. It's going to give you information on the light. This happens to be a flashing yellow. If it's a flashing yellow, I know right away it has nothing to do with navigation. It's got probably a research buoy or a buoy for anchorages, whatever. It has nothing to do with navigation because it's yellow. The next one's going to tell us the height, both in meters and in feet. It's going to tell us what it's on. If it now, a lot of luminances, if it had a luminance determination, which most of the navigation buoys would, it would be listed, and that's going to tell you how far out that buoy can be seen. Structure it's on, and again, any other information. This happens to be there from April 15th to December 1st. It's a private buoy. The height is important in a sense that the higher the buoy is, the light is, the farther out I can see it because of the curvature of the earth. If it's right on the pier, there's a good chance I'm not going to see it out more than about 4 miles. Okay. Chart one is your legend. You can download that again from NOAA. It's going to have information on just about everything, every squiggly line, bottom type, whatever, will have an explanation in it. Here's an example. Anything with, in the top one, number 2, with a line across it. First, dashed little dots with magenta usually indicates danger. It's a danger area. This happens to be cleared by either diver or by a wire down to 3.2 feet. Whatever the depth is, or the depths are defined as on a chart, be it meters or be it not fathoms or be it feet, is what these numbers relate to. On the river, they have the Blue Book. The Blue Book explains about locks and dams, what regulations there may be. The electronic charts are available from download, river elevations, river traffic, etc. The Blue Book is required on certain boats. Usually it's the larger ones, particularly the barges and that. Have you guys familiar at all with AIS on your chart plotters? Okay. You're going to probably want to learn a little about it. If you haven't, you want to talk to a rep and find out about AIS on your chart plotters. So the newer ones do have them. By AIS, I can track any of the big boats coming through. So for example, by using AIS automatic identification system on the river, I can find out where all the barges are, and I can determine if I'm going to beat them to a lock or if I'm not. If I'm not, you know how long it's going to take to lock through. If I'm out on the Detroit River, any of those areas, and I got big boats coming through in the fog, EIS is going to tell me where that big boat is so it does not run over me. So it's something that you really want to learn a little bit more about if you can. Code of Federal Regulations, when we talk about what you have to have on your boat, it's in the CFRs. Everything's electronic now. If you get into a situation where you're talking to the Coast Guard, very kindly ask them to show you where in the book they're quoting, because sometimes they know what they're doing and sometimes they don't. And I've always, if there's been a question, we say, let's look at the CFR. That is the Bible, that is the law. It will explain what they can enforce on it. Any questions on publications?
The question I had was just, is this more, I guess when it gets down to the test, are you going to say, if you're out on open water, which chart should you use? Or if you're looking for this specific information, you need to know, do you look in the Coastal Pilot or do you look in the local notice to mariners? You know what I mean? Is this just information to learn so we know where to look and stuff, or how is this going to be on the test?
You may run into something like, what updates all other publications? Local notice to mariners. There's a buoy out at the distance with a flashing light. How would I know what light that is? Light list.
Okay.
So it's going to be general stuff like that.
All right.
But it's also, and the reason I put it in there and the reason I have my test question, it is important stuff. And as I always say, when you're a wreck boater, I don't care what you do. When you're commercial and you have clients on board, then I'm very concerned that everything is done safely. And that's why I go through enough of this to make sure that people at least look at it or know where to get it. But no, you're not going to run into anything really weird.
Okay.
We can, so with that, the AIS system, we can get that to display on our Lowrance graphs on our boat?
How new of a unit?
Or they're brand new?
Boy, yes. You got to talk to the reps on that. I chewed a couple of them out saying, you guys are losing sales. You're not explaining this. But when I talk to a factory rep, he says, yeah, they always show me. We can do all that. So yes, you want to talk to somebody who knows. But it's a VHF signal that's in a little bit different band than what you have on your radios. So that AIS signal, the VHF signal is picked up by your chart plotter if it's set up for that, and will show you all the different buoys. The buoys, as I'm going to explain here in a moment, a lot of them are going away. They're virtual. Every time Congress cuts money, a buoy disappears. And what they do is replace it electronically, virtually. But yeah, all the stuff I was talking about, man, I talked to a number of people who said, yeah, that's really been a lifesaver. People that do the big loop, a lot of people that move boats, that's what they have on there, and make sure they have it. If you, at the end of this, I'm going to show you marinetraffic.com, and just dial that up, and you're going to see what boats are on. You can track what boats are now up in Lake Superior and the like. It'll mainly it's big boats, but a lot of the yachts will have it on there. And again, the buoys now are going more that way. But if they're brand new, man, you got to have it on there. You got to talk to those reps.
That's just a matter of switching something on as far as an option in the graph, or is that something I need to download into the graph?
I think it should be on there already. It should be part of the software.
Okay, it's just a matter of it showing it or not, whether it's displaying it or not.
Right. The two reps I talked to a year ago, both Garmin and Lowrance says, yeah, it's there. and then basically they hit a couple of menus and showed me right where it was. And I just shook my head because the three pro fishermen down the next aisle, they looked at me like I was talking Greek. And it's like, come on, guys, this is important stuff. So, yeah, I would check on it. And if it's there, you guys got to use it. So let me go through buoys. And at the end, any other questions on it?
No.
Okay. When I get to the end here, I believe I got a little bit on it, and we'll talk more about it. Aids to navigation, 8 tons. We need to know a little bit about why they're there, why they were established, how to use them. And I'm going to talk about the ICW, Western Rivers, the lateral marking system, and what is returning from sea. Any device external to the vessel is an aid to navigation. Sometimes they're on land, sometimes they're in the water. Typical buoy, big thing on buoys, that the deeper they are, the larger the swing ratio is. And you got to be careful about that. Fixed on land, we call them beacons, day markers. And they're going to have more of the shape, the triangles and square shapes. Western Rivers, marking system, and intercoastal. So I want to talk a little bit about each one of them. Each of them is very unique. Lateral system is arrangements of colors, shapes, and lights to show you which side to pass on. Following by the process, the convention of voyage, which we'll talk about in a moment. Everybody knows red, white, returning. And the other thing is you cannot go between two markers of the same color unless you really, really know that there's enough water there. More people have stuck their boats on mud because of that. Red, white, returning. Returning from sea, red, triangle, nun-shaped buoys, even numbers, red lights. Red even triangles is what you want to remember. The numbers are even, and coming up the system, they're going to be the 2, 4, 6, 8. As we go up the system, the numbers should be increasing. On our port side, on our left side coming up, returning from sea, it's going to be our green, squares or cans, odd number, green lights. Green, odd squares, red, even triangles. Again, they're going to be the 1, 3, 5, etc. Here's your nun shape. Not all of them are nun shape. Some of the red ones will still be can shape. Are they always on station? Nope. And that is why we use the local notice to mariners to tell which of our buoys are no longer on station or missing. The silhouette buoy tells us nothing without knowing are we coming or going from sea. Really a key part of it. Okay, direction of voyage is normally used for open water. Up on the bay, up in Green Bay, any place you're going in an open water, then we have an arbitrary system what is returning from sea. When you're going into a harbor, you're going up a river, whatever, returning from sea is where from the entrance up the system. So on the East Coast, it's to the south or west. On the Gulf, it's to the north or west. On the Pacific side, it's from San Diego up to Anchorage. In the rivers, or excuse me, in the Great Lakes, it's either north or west, except Lake Michigan, it is to the south. So when we're in open water, that is what is defined as returning from sea. So here we're going up a river system. We have our green one, our red 2, 3, 4 is not there, 5, 6, etc. up the system. Going up the system, on our port, we got green, we have odd numbers, and we got our cans. Going up the system on our starboard side, we got our even numbers and our reds, and either our triangles or none buoys. Now let's talk about open water. Here we're off a Peshtigo reef, and I see a red marker, red Aton. So the question is, how do I pass it? I have to know what is returning from sea. In Lake Michigan from north to south is returning from sea. Again, it's an arbitrary administrative determination. So the bay is the same thing. So if I see something red going towards Green Bay, I'm going to keep that on my right side, because on the other side of the marker is a reef, and boats during low water rip out their bottoms. So again, I don't have, a red and a green and all that. I have a single marker. When I have a single open water marker, you have to ask the question, what is returning from sea? And in this case, again, towards the mainland is returning from sea. So I keep that buoy between me and out. Very important. Otherwise, that will happen. This is 3 years ago when some guy didn't make it off the reef. Again, laterally significant means I have to know which side of the buoy I have to stay on. It's red right returning from sea, but when I'm going back out to sea, it's green right leaving. Red cannot be on both sides, coming and going. So here I'm coming in. Here's I have my triangles. My triangles are red. They're even numbered. So I'm coming in, I'm keeping those on my starboard side. However, when I go back out, I'm keeping the squares, the green squares, odd number, on my starboard side, because they have to be different coming and going. So I'm looking, out to sea. I'm going out to sea, returning to sea. I have green on my right, on my starboard, and I have red on my port. This is very typical in areas like Florida, shallow water, Carolinas, where they don't have floating buoys, but they have a lot of shallow areas. So I see a triangle, a couple triangles, and then I see a triangle and a square. So I'm returning from sea, so triangles, red, are going to stay on my starboard side. And that's the way I have to go around to get through. You can see the shallow water there, but in essence, that's how I have to make sure I'm following those markers. First question, am I coming or going? And if I'm coming, then I better keep red on my right side, my starboard side. Not all buoys are set up where they are two of them. These are a set of private buoys going through Charlotte Harbor, very shallow. And you notice everybody stays right along the buoys. I'm going back out to sea, returning to sea. I have the reds are on my left. They're on my right coming in, but they better be on my left going back out. Now, bifurcated. What happens when you have two navigable channels meeting and you can go down either one? What they do is they place a channel marker that's banded. This happens to be red over green, or it can be green over red. So when I'm coming in, and if I'm staying down the middle of the channel, the main channel, I'm going to follow the reds all the way through. However, if I want to take the secondary channel, I'm going between a red buoy and the lower one is green. So I'm keeping up the system between reds and greens. And I'm going to show you in a second here. Group flash, 2 + 1. So here I can go on either way. So you see the number 2 red. Well, if the next buoy up was red, I could not go that route. But if the lower band is green, so I'm going between my red and my green. So I can go either way. Go back to that for a moment. They are lettered and not numbered. Why? I couldn't make the system work because depending upon where it is, it could be buoy 2 going one way and buoy 10 going another way. So that's why we letter them, because they're not laterally significant. We can go either way with that. Group flash, 2 + 1. Bifurcated. Safe water. These are designed to line up big boats in the channel. They're going to have the Morse code A, the short long, MOA, vertically striped, white and red with a red top mark on them. Basically, again, they're not laterally significant, so therefore they're lettered, and I come in on either side. Entrances of a number of the harbors on the large chart, or going down the main channel on Long Island Sound, you will see a number of RWs. It's basically to keep the boats, the big boats, in the middle of the channel. They look like. Sector lights, you're going to see a couple of them. There's one on the chart. Basically, it says don't turn in until you clear the reds. So here's our flashes. Morse code number 6, basically our short, long, safe water coming on either side. Above that is our quick flash. It simply says change, caution ahead. Just be aware of that buoy. The one above that is our group flash 2+1. It simply says there's a bifurcated channel, you can go either way. Above that is a group flash also, and that's just 2x2. Isolated danger, just stay away from them. This happens to be, again, on the north end of Green Bay. The rocks come up to 27 feet, which is a danger to the bigger boats. Therefore, they throw that out there and just simply say, give it a wide berth. Yellow. Anything yellow has absolutely nothing to do with navigation. It's to mark a anchorage area, data gathering, weather stations, whatever. And of course, everybody's are orange and white, you know, safety, exclusion zones, no wake, and the like. Range lines. For bigger boats, like in the bay here, coming into Green Bay, especially during the season when there are no other buoys out there because of ice, basically they line up on them, and that's how they proceed until they get to a turn buoy. So this is off of one of them. This is off the other one. Again, they're designed to line up the bigger boats down the center of the channel. If you're ever on a range and you want to know if you're on the range, you look at the back one. The back marker will tell you which side you're off. So in this case, we're off to starboard, and we got to go to port to get back on the range, back on the channel. Icw, Intercoastal Waterway. This runs from New Jersey down to Texas. It's between the mainland and the barrier islands, you know, all the resorts are, and it's marked with yellow. So on the existing markers, you will see a yellow square or a yellow triangle. So anything to do with intercoastal is yellow. Here's your marks. When you put yellow on green and red, they don't quite come out yellow. But if anything comes up, I asked you anything about the ICW, Intercoastal Waterway, it is marked by yellow, triangles and squares. Mississippi River, any of the western rivers, the direction of Voyage, of course, is from the mouth of the river system, just like in any other harbor. The aids are not numbered or lettered. They're marked by mile marker, but they don't have a physical number or letter on them. And they use a terminology about right and left bank descending. And I think the next slide will explain that. Oh, again, on the left, it's got red, as we would expect. And on our right is our green, without the letters. Now, in the rivers, as you know, especially in Mississippi, it loops back on itself really badly. Up in St. Paul, it comes right back through again. So you could be standing on one bank and actually be on the west bank, but it will make you appear, because of the way it twists, you're on the east bank. So everybody can look at the water and know which way is flowing down. So what they'll do is right and left bank descending. If I'm on the right bank descending, I'm going back out to sea, right? Therefore, what we're going to have is going to be our greens, because we're going back out to sea. A lot of the Coast Guard reports will be all right and left bank descending. Locking through, never tie up to a lock. A lot of stories about that. Government first, passengers second, commercial barges third, wreck last. Now, when you approach a lock, they will monitor channels 12, 13, and 14, as well as 16. 13 is very important because that's bridge to bridge. On any big boats, they normally monitor 13. And if you really want to reach them, you go them on 13 because that's for navigation. Where a lot of times anything on 16 they totally ignore, especially on the weekends. Red, locks closed. Amber, partially open. Green, ready to go. And then, as you guys know, when the gates are open and they have a strong pull, they will put out the big red dot that says, hey, the gates are open, and be aware of the cross current. Bridge lights, not laterally significant, but if you have a multi-span bridge, on any fixed bridge, look for the greens. The reds mean don't go there because there's obstructions. Always look for the greens. And on the main span, there may be a green light with 3 whites above it. I throw this in just for your, again, edification. Earth is curved, and a lot of times people say, well, I can't reach my buddy on the radio. And I say, okay, how high are you? Well, I'm sitting on my boat, so my antenna is about 5-6 feet above. I mean, your buddy is the same. So guess what? If I add up 5 feet, you're going about 2.6 miles. If his is up about 10 feet, you add them up, and the maximum your range is, even though if you got a 25 watts, it's going to be roughly 6 nautical miles. Why? After that, they're over the horizon. So this gives you an idea how far out you can see an object on the water. Search and rescue, looking for a kayaker, 2.5, 3 miles out, they're already below the horizon. You're not going to see them. So again, it's just for your information about how far out you can see. Mentioned we were talking about those lights and how high the lights were. Basically, that one was like 30 feet high. Well, that light can be seen out about 6.4 nautical miles before it's below the horizon. Foghorns, they give you an indication there's an obstruction or a harbor out there. They will differ by location, so you can differentiate one from the other. Normally, they're in the break walls. How do I know what the horn signal is going to be? Light list. On the chart, we'll say horn, but it will not tell you what the frequency is. That you have to look in the light list to find out, as well as the fact that a lot of these are turned on by keying channel 83 5 times in 3 seconds. How do I know that? It's in the light list.
I got a quick question on that. So we have a handheld radio in our boat right now. Does it matter that it doesn't have channel 83?
Oh, it should.
Well, it goes straight past it from 82 to 84. And I didn't know if that was specifically because they don't want, just wreck boat people with those out there blasting the horn all the time.
No, that's, I would look back in the menu and find out why. The only channel that you're prohibited is channel 70. Because
Okay.
83 is, 83 is set up for that. I would look at the unit and find out why. It does not make sense.
Okay. Yeah, I scrolled through them, and that was the only one that didn't exist. Oh. All right.
That's weird. Boy, that's really weird. But yeah, if it's set up that way, that's, in my mind, it's an error because 83 does turn on the horns. That's what they prescribe it at. If you go up to Lake of the Woods, you will run into the Cardinal System. Canada plays with this. The U.S. does not. You go to any other place in the world, you will see this. And basically, their shapes and lights tell you which side that you must pass it on. So here is a reef marked up in Lake of the Woods, I believe, in that area. And that's all they're going to do. They're going to throw that out there, and basically it's going to say, you better pass it to the north. That particular one to the right side. So if you do go up there, and I've had a couple of guys say, yeah, we went up there, we saw them, we had no idea what they are. They're cardinal, telling you which side you must pass it on. And it's by compass, north, south, east, or west. So again, just be aware of them. And down in the lower 48, you will never see these. Okay, quick review. Our intercoastal waterway, Western Rivers, U.S. marking. Our marking system that's laterally significant, of course, is port and starboard. And they're going to be never go between 2 reds, 2 greens. Preferred channel, that's our bifurcated. We can go either way. Group flash 2+1, and that is again numbered. Safe water, come to me. I'll line you up in the main channel. MOE, Morse code A, not laterally significant, again, will be lettered. Isolated danger, don't go over there. Special purpose, yellow. Anything yellow has got nothing to do with navigation, it's simply to mark weather stations, research gathering, dump areas, whatever. Our normal orange and white information, regulatory signs we see all over. Wreck buoys you'll never see. Again, remember, returning from sea, it's red, even, triangles on your starboard, green odd squares on your port. Intercoastal, yellow. So you have to remember with that one. Again, as I'm entering a channel, what's going on with the numbers? They are increasing on both sides. And again, on your starboard, it's going to be even numbers. On your port, they're going to be odd. When I'm returning to sea, again, be careful. Read the question. Are you coming or going? Numbers are doing what? They're decreasing. Green 1 is way the heck out in the middle of the water there. It's not in some place buried in land. So again, when I'm returning, when I'm going back out to sea, green's on my right, not red. Here's our 3 lights that we talked about: group flash, MOE, and cautionary. And that is aids to navigation. Questions?
Yeah, is there an instance where we see a 2+2 light?
Yep, and it's simply to tell you it's a different buoy. It is simply to designate it that it's a group flash, but it's not one of those that's going to be on one of the primary buoys. I'm coming into a harbor, I'll see an ISO, one that's going to flash long, and it's off long. The next one could be a group flash 2+2, saying, hey, I'm buoy green, green 3, etc. But if I see the 2+1 group flash, that's bifurcated.
Okay.
So what does that make sense? Like that answer on
Any other ones?
I think that's it.
Okay. What we want to go on to is
actually, I have a chart question that nobody's been able to answer for me.
Okay.
If you're looking at certain charts, there's numbers that depict the depth.
Yep.
All throughout on the map, and it'll be a larger number and then a smaller number next to it. Is that got something to do with fathoms, or because it just doesn't match up with the depth in the water? Do you know what I'm talking about?
What type of chart?
Actually, on like our graph on our boat, certain chips or for certain bodies of water you'll go to will display the depth that way, and it doesn't match up with the footage that we get with the depth finder.
Okay, that I'll talk about in a bit, why it doesn't match up. But then, can you give me an example of the numbers?
It might be like a large 5 and a small 2, or.
Aha, it's 5'2".
Okay.
And it'll be 2/10. Basically, it's 5.2 is what they're saying. So they're giving you the smaller number should be 1/10 of a foot.
Okay, but I guess I've seen it on maps like out in Green Bay where you wouldn't think that you'd need the 1/10 of a foot.
It depends on what the cartographer wanted to do.
Okay.
But that's what I would say, because the other thing, if I had a better idea of the numbers, that could also be meters. The bigger one could be feet, and the small one may be meters. Because 2
All right,
meters.
I was going to say that never really seemed to match up. Like I said, I've actually probably asked 100 people that, you know, what it might have meant, and nobody's been able to, with confidence, tell me what it's meant. So actually, I'll look around and see if I can't find a map with what I'm talking about on there, and I can bring it over, you know, when we take our test.
Okay, good. Now, remember I showed you back when I was talking about chart 1, and I showed you something.
Yep.
It was clear to 3 with a small 2 next to it.
Yep.
That's exactly what it was. It's clear to 3 feet, 3.2 feet is what it was clear to.
Okay.
So they measured it down to that point. If I have the right one up here now, I'm going to answer your second question, and hopefully just a couple of minutes here. And because I'm going to go through a little bit understanding about charts and that, and I want to make sure I get the right one pulled up. Yeah, that should be the right one. Okay. We're going to talk a little bit about charts, and I like your question because I think we can answer it here. We talk about working with charts, compasses, plotting courses, speed, time, and distance. Aids we just talked about. Publications we already talked about. Okay. The world, lat long. We live by lat long. GPS runs by lat long. People can't drive their cars without it. But basically, it's a reference system we learned about, I think, in 5th or 6th grade. Parallels of latitude, meridians of longitude. So any place on the Earth, it has a unique number by lat and by long. Now, we're going to do on the charts, we do tenths of a minute. On most chart plotters, they will do seconds. I can't do seconds on our charts because of the way the increments are. So we use tenths of a minute. And in your GPS, if you got it in seconds, all you do is push one button and it'll convert it to tenths of a minute. Latitudes, equally spaced, north and south. Imaginary line from the middle of the Earth out to the surface. And again, subscribing circles north and south of equal distance apart. They run across on the charts. North is always up on a chart. Even if it's in the southern hemisphere, north is always up. Meridians run north and south. And these are formed by slicing the Earth. So here we slice the Earth into wedges. And the distance between them is 60 nautical miles only at the equator. And as we go north and south, they converge until they meet on the north and south poles, basically to infinity at that point. So we never use the meridians, the longitude, to measure distances because they're not equally spaced apart. Prime meridian is in England. And then as we go around, we got the eastern and western hemispheres. They meet at the international date line on that. Circle 360 degrees. We write degrees with the little degree sign, even though most of the time I ignore it. 60 minutes in each degree. So if I asked you something's 2 degrees away, how far is it? 120 nautical miles. It's basically 60 nautical miles per degree. And also has 60 minutes. And we write degrees like you see there, 14 degrees, 15 minutes. The next one down, we're going to say, we're going to go to the 10th of a minute. That's meant we can work with charts. Because it's a tenth, we use the decimal sign. So 24 degrees, 45, and 2/10 is written 24, 45.2. 45.2 minutes. There are basically, by doing the math above here, 21,600 divided by 360 gives us 60 nautical miles per degree. 1 minute equals 1 nautical mile. You measure a distance and it's 3 minutes apart, 3 nautical miles. And a nautical mile is 6,076 feet. And again, it's only measured on the latitude scale. Speed is in knots. It's not knots per hour. It's basically 5 knots means we're traveling at 5 knots per hour. On the charts, and I want to make sure it's clear because it gets a little confusing. You're going to see gradations here. What I have is 1 minute. Within that minute are 10 tenths. So the little ones are tenths, and if you have 5 tenths, you'll see a little bit larger line, but there'll be a shade or color difference between the minutes. So when we count minutes on the chart, you make sure where you count it. And I always suggest that when you count minutes and you're using your finger or marker or whatever, you always go to the edge. Don't go to the middle. Because what people will do, they'll go 1, 2, 3, and they'll say it's 3 minutes, but in reality, it's 2.5, or just the opposite. So you want to make sure you're counting full minutes when you count distances. Chart projection, take a round sphere. You can't put it on a flat surface, so you have to project it out. The main one that's used is Mercator. If I ask you what the primary projection is on charts, 95% of them, it's the Mercator chart projection. It's also listed at the top of your chart. Primary way, basically we're putting the globe on a flat surface so that the meridians are parallel. In reality, they're not. But the distance we're covering, you don't see the difference. Mercator projection. And again, the latitude's on the sides, longitude's top and bottom. You do not use the longitude ever to measure distances with your dividers. And I'll show you that here in a moment. All charts have a datum. On the Great Lakes, it'll be 577.5 for Lake Green Bay. On our tidal chart, such as the one you're working on, it'll be the mean lower low water. Now, let's go back to what you were talking about with your depth finder and your charts. The chart datum is based on a survey of the lake saying that it is at 577.5. When you go to Local Notes to Mariners, it's going to tell you that the lake is up or down. I think right now it's like, say, 22 inches, I think Green Bay was. That means you have to add 22 inches to anything that's on your chart plotter to give you an actual depth. If it's below the datum, then obviously you're subtracting. So your chart plotter, your depth finder, is reading actual depending upon where you have it. If it's calibrated to the surface or to the bottom of your boat, that's number one. If it's calibrated to the surface, then the difference between its reading and what's on the chart plotter is probably the change in elevation due to runoff, snow melt, whatever. That should compare to what's in Local Notes to Mariner, because they give you water depths on a weekly basis. If they don't, then something else is screwy. But that would be probably the first thing I would look at. So right now, if it's, I don't know if I think it went down a little bit, but last time I checked it was about 22. Say it's 2 feet. So if I'm in the chart plotter says I'm in 72 feet of water, my depth finder probably is reading 74 feet because the lake is up 2 feet above the datum. Hope that makes a little sense. Soundings will be posted. Usually there's soundings in feet. Now we talk about all these lines, Colregs line, boundary line, territory, and the like. This just gives you an example. This is at Chesapeake. This is at the bridge. The first line there is the Colregs line. That means to the left is inland waters, inland license, inland rules. To the right of that is international rules, not international waters, but international rules. Therefore, with your license, you got Great Lakes time, you're going to have a near coastal license. You can go 100 miles to the west of that line. The next one is boundary line. This indicates what is officially inland and coastal waters. So when it says on your sea service form, it says, are you seaward of the boundary line? That's the line that they're talking about. The next one is your state line, 3 miles out. That's where food waste, all garbage cannot be dumped on. Between that line and the territorial line, which is 12 miles out, is where food waste ground to 1 inch can be dumped. Beyond the territorial line, that's international waters. So between that line and inshore, that's state waters, or federal waters rather. So those are the boundary lines that we've been talking about, just to give you an idea. Again, the information block on every chart is going to tell us chart projection, feet, and the main name of the body. North end of Lake Michigan, Green Bay. Scale is 1 to 240,000. Depth is in feet. And again, the water elevation is 577.5. Everything's going to have a note 1. Note 1 says read coast pilot and local notice to mariners. It's their way of covering them. Just like when you turn on your chart plotter, it says that a prudent mariner will not use just one form of navigation. All those are just their proper legal warnings. Now, in the lower left corner of all charts, you'll find the chart number. The date it was updated. The data was updated by notice to mariners and then local notice to mariners, and then the addition. The lower left. Compass rose. We talked about compass rose. It's on the charts. In the middle of the rose is variation. And as we talked about before, you always use the outer part of the rose. And that explains charts. Any questions on charts? Okay. I'll get into a little bit more exciting stuff.
Do we have to add that that yearly variance?
No. Only it is so small that you're not going to be doing it. You buy a new chart every 3 to 4 years anyway. You should be. Your compass is not going to read that. Like I say, if you do determine your deviation table for your boat and it's less than 3 or 4, you're not applying any of that. You're just not going to see it.
Okay.
But yes, if you are using a very high-end compass and sighting, and they would take that into account, we're not. Okay. Now any other questions?
No.
Okay. Now I want to talk a little bit about plotting and what we got here. A dead reckoning. The term dead reckoning simply means our approximate course based on speed, time, and direction from our last known fix, without consideration the current, wind, or other forces. So we're leaving port and we're going to be going 15 knots at 220 and we're going to travel 1 hour. We should be 15 nautical miles off from shore. Once we look at our GPS and other things, we find out where we actually are. So a dead reckoning is simply our course. When I talk about on your charts, you draw your DR. That's your course that you're planning on driving without any consideration to other external forces. And always from a known fix. A known fix is high degree of accuracy on it. We talked about our distances, nautical miles. On lakes and on the river, it's statute, but we're dealing with nautical. Speed is a knot. Everything we're going to deal with, time is in minutes. We're going to convert to hours, but everything we're going to do is in minutes. And again, distances we're going to do to the closest nautical mile, 10th. Speed to the closest 10th, and time to our closest minutes. Okay, 60 Street. If you're good at math, the 3 formulas work out perfectly. For those of us who are not good at math, we use 60 Street. It helps us solve our problems. The biggest thing on 60 Street is the 60. 60 stands for 60 minutes in an hour. This way, when we do the math, it comes out 2 minutes, not tenths of an hour. And I'll tell you, trying to teach people how to do a 1/10 of an hour, it's not there. So we simply convert everything 2 minutes. It's the simplest, the easiest way of going. The other thing to keep in mind, and this is why people run into problems with smartphones, there is not 100 minutes in an hour. It is 60. So when people try to divide and do certain things with smartphones, they get wrong answers. In fact, we had a math teacher on our last NAV exam, plotting exam, got one wrong because he used 100 minutes in an hour and not 60. So that you got to keep in mind, a lot of this stuff ends up being done by pencil because the electronics don't always do it right. Now, I've always asked, how to explain this. We multiply across, divide between. So here's an example. We have our distance is 10. We're going at 10 knots, and we're traveling. Oh, excuse me. We're traveling at 10 miles an hour, 10 knots for 35 minutes. So how far are we going? We take where we have two numbers in there, we multiply them across, 10 times 35, and then we divide by 60, and it will tell us they were approximately 5.8 nautical miles. So in your books, there's like 21 problems in this section. I tell everybody, please do them, even if you're very good with it, because it helps you catch errors on that. But 60D Street, when you do the exams, I strongly suggest you use it because it's going to make a big difference. I'm going to go through one example. Okay, 10 knots, 3 hours, 45 minutes. How far did you go? What's the distance to the shipping channel? The first thing you have to do is convert it into minutes. We don't deal with hours. 180 plus 45 gets us 225 minutes. And quite frankly, you'd be surprised at some of the answers I do get. 3 times 60 is 180 plus 45. Do it by pencil. It comes out to that. So we're going 10 knots times 225 divided by 60. It's 37.5 nautical miles away. So when you look at the problem, I got two variables that I have. I got speed, 10, and I have time. So that means I'm going to solve for D, which is distance. So you write that into that 60D Street. It helps you decide what you have, what you need to solve. So if you're very good with math, no problem. But for a lot of us, this really helps to help solve the problems and basically minimize any frustration, which is really key on it. Okay. But again, there's 21 problems. I strongly suggest, if you haven't, to do them. And again, get into that mode of how to fill in 60D Street. And again, the exam part is a no-brainer. The other thing is I use this a lot when I travel. I'll give you the example that you're out there, and when your prime very high tipper client says, hey, can I fish 10 more minutes? If you know how far you got to go back, now you have distance times 60, and then you factor in when you have to be back within 10, I have to be back at such and such time, I can determine how fast I go. So again, by factoring in those items, it says, okay, instead of going 15 knots, if I go 20 knots, I can let this guy fish 10 more minutes, and I'll probably end up with a bigger tip. It really does equate. Check in. You got to get back in time for a weigh-in. Where are you? How far you got to go? How fast do I have to go to get there in time? Again, all of it really does help out and our daily boating. Bearings, horizontal direction from one point to another. So I take my compass out, I take a bearing to an object, and I report it in degrees. Now, there are 3 tags. And gentlemen, it's very important when you read problems to make sure you read the whole problem in particular tags. Is it true? Is it relative? Or is it per ship's compass? Now, per ship's compass, you're not going to find. But you could run into relative, and I'll talk about that in a little bit here. Of course, is the direction your vessel will be heading in. Heading is where actually what the bow of the boat is pointing at. Again, remember, dead reckonings are approximate position based on, from our last known fixed, high degree of accuracy, again, without regard to other factors. Our position, everybody does lat long. We know our position by lat long. However, I can express it in a different manner, and that's in a geographic location. I'm going down. I don't have a time to read my GPS. That end of the boat's already underwater. I grab my compass. I take a bearing off a tower, and I can tell them I am, 5 miles off of such and such a tower at this heading. People can find you. And even talking to one of your associates, if they want to know where you are, you can give them a bearing off a known object in approximate distance, and they can find you. So don't always just think GPS. It's lining up the old church steeple with the big oak tree to get you in the right spot. Okay. Again, estimated position, we have some data, but not enough to be sure. ETA, our expected time of arrival. Fix, a high degree of accuracy where we are. We always start a DRR from a fix on it. Line of position. An LOP is a bearing to a known fixed object, something that's on the chart. And we're going to talk about LOPs here in a little bit. Line of position. I got to be on that line at someplace on that. Speed of advance, average speed needed to arrive, speed made good. Again, the same math will involve how fast did we actually travel on an average. Course over ground, our actual course, our course made good is one in which we're going from point A to point B. Course over ground can be extremely dangerous, just like you see in this example. Your GPS is pointing to a waypoint, but you can be pushed off and into danger area, even though the GPS is still pointing towards your waypoint. If you have not used, please try highway mode on your GPS. I got an example, I think, coming up here on how it can be done. If you have not done that, please look at your chart plotters and that, and you can find out it can get you back to your way in quicker. If you're getting pushed with set and drift, it'll counter that, etc. And I'll talk a little bit about that once we talk about some actual plotting. Marking. Now, you guys most likely are not, but if you're doing an overnight, if you're doing a longer voyage and using your charts, they should be properly annotated. So basically, a dot and a circle means that's where I am, confirmed. And again, the half circle is our estimated position based on our speed, time, and distance. Relative bearings. Everybody does, 1 o'clock, 5 o'clock. I got your 6. Out in boats, we do it by degrees. So straight ahead, off the front of the boat is 00360. Off your starboard, a beam, which is basically 90 degrees off. The starboard side is 90, dead astern 180, port 270. Relative bearings. You're out on the front of the boat. You don't have a compass. You see something that you want the helm to know about. You give it as relative bearing. They add that to the ship's heading, and they can actually plot it out. So here's what we're talking about. 90, 180, 270, 360. Okay. You see something, again, these are on the quarters. So I see a boat overturn, and I look at front of the boat, and I say, okay, it's got to be about 300, 304 degrees. Relative. The helm says, okay, they look at the ship's heading, which is 145 true. They add them. Any dealing with relative bearings, we simply add. There's nothing more complicated than that. We add them. If it happens to be over 360, which does not exist, we subtract 360. So in this case here, I can draw a true bearing to that boat that's flipped over at 89 degrees true. Relative bearings, all we do is add them. There's nothing more simpler than that. Maybe a distance off is the same thing as 2 lines. We add them. Heads up radar. A lot of people run radar. They run it a heads up bearing off of radar is relative because it's set up to the front of the boat. Again, it's over 360. We simply subtract it. Okay, any questions? Okay. Dead
nope,
reckoning.
we're good.
I think dead reckoning is what we have to do next. And then we do pod. Okay. Now, when we talk about plotting, we are only going to work on 3-point fixes, distance off, speed, time, and distance. we're not gonna bother with running fixes or set and drift. They're good things to know, but we're gonna push them off to the side. Now, the compass rose, when we measure distance or directions, a compass rose is simply that. It's going to give us an angle. It can be placed anywhere on the chart. Doesn't make any difference. It's simply we're getting an angle, a bearing on our compass. True north is up, and that's all we use the rose for. When we do take our rulers and we walk them over, we have to go through the little X in the middle. And we have to make sure we're using the outer rows. And third, we have to know which direction we're going. That's why on the chart, when you chart things out, I always suggest you put in an arrow which way you're going. So from B to A, that our bearing is going to be 155 true. Notice the tags on them. If I'm going the opposite direction, it's 335. Obviously 180 degrees difference. So again, make sure you read the right side, the correct side of the rows for the DR that you have. And always go through the middle. That's very important. Again, we have true is geographically, it's our GPS. Compass, per ship's compass, we factor those in. Relative is the front of the boat. Relative and true are what we're going to deal with on it. Again, we know a nautical mile is 6,076 feet. 60 nautical miles in 1 degree. 1 minute is 1 nautical mile. Now, when we measure distances in that, and I'm going to show you that in just a little bit, we take our dividers. They really shouldn't be spread more than 5, because these dividers, when you start getting between 5 and 6, you start getting stretched too far out, you're going to get some bad answers on it. So we put it on the 2 items, and then we basically take it over, put it on a whole number, and then read up from there. So this happens to be about 2.7. Again, remember, each one of those color differences is 1 nautical mile. So that's about 2.7 nautical miles. If it's more than that, then we set it at 5. On the latitude scale, we set it at 5, and then march it off. And if there's a little bit at the end, we just simply squeeze it and add that to our number. Again, I'm going to come back. These are the sheets I was talking about. What I want to do is finish this, and then I'm going to come back and actually show you. I got the other camera set up. Again, time is, everything's 2400-hour clock. You got to remember 60 minutes per hour, not 100. It's really one of the key items. Careful with your math. A lot of it's going to be, again, hand. Line of position, our LOP from a fixed known object. Here's our LOP. We took a line of position off an object. We can line that up on our chart and draw that line. We have to be someplace on that line, but it's not a fix because we can be just about any place on that line. So here's how we would do it. We take a bearing, we go to our compass rose, We get that angle, we march it over, we draw that line, and we're someplace on that line. So it's not a fix, it simply says we're someplace in that area. Okay. 2 lines of position. If they are too close or too far, it gives us a location, but not very accurate. What we really need are 3 lines of position. We have 3 of them together as our 3-point fix. You come out fairly close. Now on our problems in our exam, if you're within, I'd say, less than a half inch, your square, your triangle, you're good. If you're more than that, you better go look at what buoy you had. Make sure you walk your ruler back to check that out, because a lot of times what will happen is as you're moving your ruler, it'll slip slightly. And again, if you have a big triangle, there's a problem. It should be fairly tight. So here's our 3-point fix from 3 objects. Again, what I mentioned before. Okay, what I want to do is I want to switch the other camera. So here's our 11 by 17. And I just want, you may well have done this stuff, you may have no problems with it, but I do want to review it just to make sure. The big thing, again, anytime I take a bearing, is I want to make sure of that little X and that I use the outer rows. So let's go up to I and J, and we're going to draw our line. And so I'm going through the little X, I'm going through the base of the light. And what I do is I'm going to press down and lift up. And then I'm going to roll it down. I got a little bit problem there with the, and I'm going to place it on the little X, and I'm going to read. And right there I have 080. So this is, my bearing is 080, true. And again, I read it this way, because I'm going from here to there. You want to make sure that's, again, now, let's talk about distances. X and through the base. And I'm going to come over and I'll put it on a full number. Make sure you can see it. And what I have is 1, 2.2. So that's 2.2 nautical miles. So again, each of these represents 1 nautical mile. And again, the tenths are in between them. Any questions? That is.
Did you say that you go through the base of the circle or the center?
Oh, the center. It's supposed to be the center of the circle. I'm off it just a hair. If you have the asterisk, it's off through this. So if this is a range, this is a range line. So my range line, all I do is draw a line. Be careful that this is the top mark. The base is here.
Yeah, but you go through the middle. Okay.
So again, really the key is, let's say I want to do a 060 off of this buoy here. What I will do is align that up, little X. I'm on 60 degrees. Again, I push down, lift up. These are a bear sometimes to do on this. There's my 060. So a 3-point fix, what we would do is I would take, again, the readings off of this. And what I'm hoping to do is have something that should look like that. That's what I'm after on that.
Yep.
that is pretty much everything we're going to do on plotting is there. We make sure we read off the latitude scale, and then bring things together. Now, on the charts, on the bigger charts, there's a couple very, very important things. And I'm going to have to grab, I think I got one out in the other room. I'm going to grab it. First is we always read from right to left, bottom to top. And that is because the numbers are going up. You are not doing any math trying to subtract. And that is what really, really, really gets people in trouble. So that's one of the key. Let me go out and grab that one chart. I'm going to show you exactly what I'm talking about and how to do a lat long the simple way. I'll be right back. Okay. Now, I want to get the location of my 3-point fix here. What I do is I take my rolling ruler and I make sure I'm on a meridian because I want it parallel. It's got to be parallel. And I'm going to roll it over to that mark. Do you notice how I got it so that I'm not reading through this? And I'm going to read it now. We know this is 72 degrees, 10, 11, 12.1. So this is 10 degrees. This is 11 degrees. This is, should have my glasses on, probably 12 degrees. So I'm going to write this out at 72, 12.0 minutes. Okay, now I'm going to show you another trick that's really going to make a difference, because when you're in the middle of this chart, you can't bring your rolling ruler off to the latitude scale. So what I want to do is, again, here's one of the latitude lines right here. So what I'm going to do is I'm going to place my divider on that, and I'm going to go up to my mark right here, and I'm going to come across, and again, I'm going to put them on right on that latitude mark, and I'm at 41 degrees, and I got 1, 2, 3, 4.1. So my latitude is 41.04.1. And that's the easiest way of doing it, is a combination of the rolling rulers and the dividers. And again, especially with the rolling rulers, you always want to do it, if at all possible, so you're reading up to the scale. You want to read up to this. You don't want to be reading through it. And it makes a world of difference. And again, as you count, always go up, because we're adding, and the same thing with the latitude. If I'm going to use my rolling ruler, I line up, make sure it's square, I move it up to wherever, and then I'm reading up to that, and it's a heck of a lot easier, not making mistakes. Does that make sense?
Yep.
Okay. That is really important. If you understand those things, plotting is pretty straightforward all the way around. Okay. I would kind of like to finish up on this part today. So if you guys can hang in with me, what I want to do is do our 3-point fixes, and then I'm going to touch on weather and tides, and then we're sitting good on that part of it. So it should be distance off is what I need. Come on. There we are. Okay, so what have we done? On our charts, we understand how to read our lat long. We understand north is up. We know that we use the latitude scale, not the longitude for distances. We know a 3-point fix. We use our compass rose to give us an angle, which you march over to the particular buoy. We draw our lines, and I just showed you how to do the lat long off of it, and the trick that really makes it a lot easier. You're going to see a 3-point fix, your speed, time, and distance. You're going to do a line. I'm going to ask you what your heading is, what your course is. I'm going to ask you how far you ran on that, and I'm going to ask you what your ETA is. So those are those problems that we talked about, those 21. The data you're getting to solve those are basically what we did off the chart with that. The last charting one is distance off, and it is pretty straightforward. You want to know how far off an object you're going to be when you pass it. You are not going to it, but we are passing it. It could represent a security zone. There could be a reef in front of it, whatever. We want to make sure we're far enough offshore. The GPS is not going to do that for you. So what we need to do is very simple. There's our course line, our DR, and we're going to do a 90-degree angle off our DRs, not the chart, it's off the blood reckoning line. That 90-degree angle is how far off we will be with our closest point of approach. That's all there is. We measure that distance, and it says, okay, I'm going to be 2.2 nautical miles off when I pass it. If I want an ETA, then what we're going to do is measure the distance we're going to travel and plug it into 60D Street. So I'm going 60 times 12 nautical miles. My speed is 9 knots. I'll be there in 80 minutes. 80 minutes, if I leave at 10, I'll be there at 11:20. And again, on the charts that are our practice sheets, there's our DR, there's our 90-degree. And if you notice on the rolling rulers, there will be a 90-degree angle in the middle of it, and that's what I use to draw that line. I just line that up on our DR, draw the 90-degree. That's your distance off. We measure that distance to determine our ETA. Okay. Any questions on distance off? Really it's really simple, straightforward. You just got to follow the steps.
Yep, we're good.
Okay. I'm going to hit tides, and then I'm going to finish up with weather. And then it'll take about an hour for this thing to process. And if anybody wants to go back, look at it again, it'll be there. So let's find my tides. Come on. There we are. Tides are pretty straightforward. They go up, they go down. Currents come in, currents go out. Now, you guys, gentlemen may well fish tidal waters. Your license is going to let you go out 100 miles into the ocean. If you're doing anything, Long Island Sounds, Chesapeake, you're going down to Florida, whatever, you're going to have tidal waters. And tidal waters is basically of the gravitational attraction of the sun and moon, and it's the vertical rise and fall. Tides are vertical. Low tide, the lowest point of that tide. High tide, the highest. And then a standing tide is where there's no change. Standing tides can last for 10 minutes. They can last for an hour before they start draining out again. Currents, flood. A flood current obviously is flooding the land. An ebb current is going out. Slack water is when there is no change. The direction of the current is called set. The speed of the current is called drift, set and drift. What causes tides? Basically, the attraction of the sun and moon, with the moon being the greater one. It forms two aqueous bulges. Part of it is caused by centrifugal force. The Earth goes through those two bulges twice a day. They go through one, 12 hours later, they're going back through the other one, as it makes this 24-hour around. So the tides are not going around us. We're going through the tides, through the bulges. Again, it's caused by centrifugal force. The high tide closest to the moon will be the highest. The tide on the opposite side will be lower. So there's a difference between the two. Now, as the moon goes around the Earth, you're going to get, on the quarters, it's going to be called a nep tide. When it's the sun and moon are in alignment, it's going to be called a spring tide. The new moon is going to be the highest tide because they're on the same side together and exert the largest attraction. And again, when you fish tidal waters, the guys will watch this very closely because they also can tell a lot where the fish are biting or not biting, where the currents are going through. High tide, low tide, nep, and spring. Basically, the difference between a lunar day and the Earth day is 50 minutes. So if we divide that through, a tide cycle is roughly 12.5 hours. To go from high to low, low to high is roughly 6 hours on it. Again, tides are vertical, rise. Again, currents are horizontal. Semi-diurnal, most common, 2 highs, 2 lows. And again, one of the highs will be a little higher, one of the lows will be a little lower. Mixed semi-diurnal depends upon the geography. Tide heights is all determined by geography. It could be all over the place. And then diurnal tide, the only place I'm aware of is the Gulf of Mexico, up by Pensacola. That area has 1 high, 1 low, and it's not very pronounced at all. Like a foot and a half. So here's your 1 month of a tide cycle. Here's your nep tide. Again, there's your spring tide. You notice on the left, the tides are pretty high. That tells me the sun and moon are on the same side of the Earth. On the other side, they're not quite. So this is why the tide cycle, the changes on a daily basis. Now on charts, you're going to run into 2 terms. Mean high water, that means the tides, the depth from the tide to the height of the bridge, your clearance. Mean lower low, they'll take the lower of the 2 tides, average out about 19 years, and then we'll use that for your chart at depth on a chart. Where on the lakes, it's based on a datum. Out on the tidal areas, it's all based on calculation. So on all our charts, it's going to be mean, lower, low water. Okay, tides go up, tides go down, currents flood in, currents flood out. They're horizontal. Currents go horizontal, tides go vertical. Now, where do we find tide information? There's roughly about 3,000 stations out there. They will give you full predictions of it. They're monitoring. Then they will have a set of substations. Substations is an algorithm off of one of the reference stations. In the past, we had to do our calculations. We don't anymore. So it's kind of mute. Current locations are about 2,700 or more. It's going to give you a direction, and it's going to give you a speed, set and drift. So here we are off of the Battery in New York. And all these elevations here are based on mean lower, low water. So at the Battery, we have our tide table here. On the 16th, you look on the 16th, you're going to see 4 tides. 4.4, that's our obviously our high tide. 0.2 is our low. 3.7, 0.1. So you can see the 2 higher tides. One's at 4.4, the other one's 3.7. Obviously, the 4.4 is where that is facing the moon on it. So you're going to get those little changes. Now, what we would do is we would add that to the charted depth. So if it's 47 feet there, we would add 4.4 to that, so that at 4 in the morning, that location on my depth finder would read 51.4 feet. So what you're doing is you're taking the tide information and adding it to the depth in your location. That's where it's being used, how it's been used. I'm going to run through just one of these quickly. Application. Okay, I'll give you an application. Again, you're in your smaller boats, but think of yourself in one of the 100-footers, 60, 80 footers. You draft 5 feet. Your charted depth is 22 feet. At high tide, when you leave, it's 3.6 feet. So what's our depth below our keel? Well, what we're going to do is we add the 5.6, which gives us 50. That's going to be 25.6. And we're going to subtract the 5 feet for our depth. So we're going to have roughly 20 feet, 20.4 feet below our keel. So, you know, people that sail in the Bahamas and do a lot of these things, this becomes very critical. If you have a keel that's 6 feet and a lot of the areas are 5 on passages, you know you got to catch the tide at the right time. And so that, for these people, this is very important. Again, our currents, they flood, they come in, they ebb out, slack water. Again, speed is direction, drift, speed is drift, set is direction. Again, here's a current one, slack water. Then we have max current plus 1.4, slack water, max ebb current 1.7. So it's coming in at 1.4, flooding, and then at this time is ebb out. The max currents are not at high tide. As the basin fills or empties, you're going to get a max current, but as it reaches its empty point or fill point, it will slow down. So your max currents tend to be different than your high and low tide. So again, for people that are going up in a river system, especially sailboats, this is very important because how fast you're going to get up or not. If you're down tarpon fishing down in the Keys, this is very important because you know which bridge to go under, when to be there, because when it is at flood, the tarpon will be up there and that's when you're going to catch them. And there's no current or it's ebbing out, go home. A lot of people use this data for different reasons. How do we do it today? We go out to tides and currents. We click the area we want. It's all on an app. Again, this is an example of Naples. We're running from about 3.5 feet. The 2 lines, one represents, the blue represents predicted, and the other line represents the actual, how close it is. And the squiggly through the bottom tells you how accurate it is. So it's going to tell us what we can expect out there. So we're not doing any calculations. We're just looking at the chart here on the app. Here's the newer version. We can click on a time on this and will give us, I know it's hard to read, but it's going to give you the depth. It's going to give you all the data right there. So now with all the new apps that are out there, you load that up, you click on what time, where you're going to be, and it's going to give you exactly the height of the tide, the time, the whole bit. No more calculations. This is one of the tables for current. You can see flood is fairly slow coming in. Ebb is up to almost 2 knots going out. What is a sesh? Anybody that fishes the bay knows what a sesh is. It's an oscillating wave that goes back and forth based on wind. And on the bay here, if we get a southwest wind, the lower bay may not have much water. If you're up on the north side and you get a south-northeast wind, you may have to drive down to Cedar Creek to get your boat out because there won't be any water in the flats. So sessions are, again, wind-driven. This is Lake Erie. They go from a -8 to a +7 change with sessions. So you can see how much that water's gone out. 30-knot winds for 24 hours. The boats are sitting on the bottom. It's another example of it. It's also when you fish that area, sometimes with the tournaments, depends upon the winds. There may, on the west end of Lake Erie, in the flats, there may not be much water. All depends upon which way the winds are blowing and how long they've blown on it. Okay, any questions?
No, I think we're good.
Okay, I know everybody's getting tired. Let me hit weather and then we're done. What I have left is deck to cover, and that'll take about 2 hours, and I want to do another rules review. Do you want to do that tomorrow right away, or do you want to do that next week? What would you prefer?
We probably prefer to do it next week if that works for you.
It works perfectly. Let me cover weather, and then we'll set that up again for next Tuesday. These are going to be out there. It'll take a while to process, and then they'll be out there if anybody wants to go back through it for your edification. But I'm hoping this is helpful. I'm hitting the high points. You've gone through the material. If I cover something 2 or 3 times, it's probably a good indication you want to know what it was. Weather is my last one. And if you got questions, just drop me an email. I'm always happy to. Okay, rules. There we go. There's a couple takeaways in weather. And again, it's really good to have an understanding of what's happening out there for your safety, if nothing else. The sun basically generates our weather. We're going into spring. We get more sunlight. We get some very interesting changes in our weather. The sun basically does not go above and below 10 degrees. That's our Capricorn and Cancer. Sun never is overhead where we are. It's always at an angle. This is the area that gets the most sunlight. We have bands of highs and low pressure north and south of that. Forms the doldrums, trade winds, and the like. So again, the sun pretty much drives what we have. Jet stream, right now we're under the southern jet, thankfully, because we're getting warmer weather. A couple weeks ago, we were under the northern jet, and that brought down some pretty cold weather. So again, the jet streams are at height. They can travel 275 miles or more. They just had a plane. They went from west coast to east coast, got one of the jets, was traveling over the ground 800 miles an hour. 800 miles an hour, which is well beyond the speed of sound, except it was within the jet itself. So again, they have a major impact on our weather systems. Normally, the air masses north and south of them are controlled by that. So when the northern jet comes down, we end up getting cold weather. When it goes back north and we have the southern jet, we tend to have much warmer weather of it. Trade winds. Anybody that does the Caribbean or Florida will see the trade winds. These are seasonal winds that this time they are increasing. They go around a high pressure area. And then when you're in Florida, if you're by the trades, the winds are coming out of the east. If you have a front coming through, they're out of the west. So down there, these become more important on open water travel of it. Up here, we got our prevailing westerlies. Our winds tend to be out of the west. Storm systems tend to cross. Occasionally, we'll get one that backs up, but for the most part, everything comes out of the west. And again, it just shows you our general weather patterns for the area. Highs and lows. High pressures are normally found in the middle of an air mass, while the lows are along the edges. The low and the front really dictate the change in the weather, be it a warm front or a cold front. Highs, they're in the middle of the area. They're kind of hard to define. It's kind of that big glob out there. But a low is very definable. And again, we have our fronts coming off of that. On the low, it's counterclockwise movement. The air is being pushed up. As it's coming up, it becomes colder. The colder it becomes, the less it can hold for moisture, and that's why it produces our rains, and generally stormy. Low pressures normally mean stormy weather. Highs are clockwise. They are descending. As air descends, it warms. Warmer air, more water moisture. Again, clouds tend to dissipate. And we've been under a high the last couple of days. It's actually been nice. So we have our fronts. We have our warm front. I'm only going to talk about two of them. Our warm front, basically it's warm air going into cooler air. And of course our cold front, more of a temperature change from cold air to warmer air. They're passing. Anytime a front passes, we know that by wind direction, temperature, and barometer change. Those three things tell us what happened with the front. Pressure gradient. High to low. It's a horizontal distance between the high and low, and it's the gradient. The steeper the gradient, the higher the winds are. We had some really horrific winds a while back, 60, 70 mile an hour winds. We had a very, very tight pressure gradient. When the pressure gradient is not as steep, the winds are a lot milder on it. So pressure gradients are horizontal. The isobars, which are bars of equal pressure, help tell us what the speed will be. Okay, there we are. These are isobars. At height, those are the directions the wind is. It gets closer to the surface. We have other effects that twist them. Clouds. This happens to be burning sugar cane fields. We have lift. We have moisture. We have particulars. What do we have? We form clouds. Anytime the dew point and temperature are within 2 degrees, you will either have cloud formation or you will have fog. Cirrus are the ones way up on top. They're ice crystals at height. They tend to be these wispy clouds. From the time you see those and they start filling in, once they're filled in, about 12 hours later, on an average, you will see a change in weather, snow, rain. They're a precursor to the warm front coming in, and as those clouds descend, we're getting into our rain. So again, the cirrus clouds are a good indicator of weather change. Mid-level are alto clouds, altocumulus, alto stratus. Anytime we get out there and it's just a boring day, clouds are at height and it's just layered over, those are alto stratus. And of course, cumulus are little cotton balls. On the bottom, when you can't see the top of the south tower, that's our stratus clouds. And if they're raining, it's stratus nimbus stratus. So at height, the only one that you only want to be concerned about is cirrus, because cirrus indicates the change that's happening. Again, I mentioned that fog, when air temperatures and dew point reach about 2 degrees, we get fog, and of course at height we get clouds. The one type of fog we get is called advection fog. It's the horizontal movement of cold or warm air over water. In wintertime, it's warm air moving over cold water. We get our lake effect snows and the like. Or this time of year now, we're going to have some warmer air coming over our cold Lake Michigan. We're going to get fog. Advection fog. Now, weather prediction. We're looking at the direction and rate of change. Very important. If it's a gradual change or no change, things aren't changing at all. If it's a rapid change over time, there's a change ahead. Now, if it's a rising barometer, we know that a high pressure is coming in, it's clearing. But if we have a rapidly changing barometer and it's dropping, that's an indication, of course, storms are coming in, particularly low front. So it's the direction of change as well as how quickly it changes that we want to look at. Anemometer, wind speed and direction. Barometer, it tells us our atmospheric pressure, and that, of course, is calibrated to sea level. We want to know over a period of time, because a one single reading means absolutely nothing. We have to have a number of them to tell us what's happening. Again, stormy weather, low barometers or dropping barometers. One direction, very important. When a front is passing, the direction of winds will change, and which affects basically our maritime jobs and that. When the low is south of us, the winds tend to be out of the south east to east. As it passes below us, winds tend to go from east to northeast to northwest. This is the opposite. When the low is going north of us, the winds again will start out to the east, but will swing around to the southwest as the warm front passes. And once the cold front passes, will dramatically go over to the west and then to the northwest. So the direction that they change is very important. And you can know if the low is going south of us, what's going to happen versus going north of us. And they can help us on deciding where to go. Again, cirrus clouds, when they fill in, the ring around the sun, the ring around the moon, indicate change. So here's the warm front coming in. We have our cirrus clouds, cirrus stratus, our mid-level clouds, and then rain. As the warm front passes, rain ends, skies clear, warms up a little bit, and the winds tend to become gusty out of the southwest. These are not violent storms. They can hang around for a while. Cold front is just the opposite. They can become very violent. We have our squall lines, tornadoes, and the like. We have a dramatic air change between warm and cold, which drives up the clouds. Because of that, we've got our thunderstorms developed and our squall lines. So, again, various conditions. As it approaches warm temps, dropping barometer, winds out of the southwest. There's a front coming through, a cold front. Once it passes, the winds switch to the west, northwest, north. Temps fall, barometers rise. Anytime we have falling temps, rising barometers, the winds are going to veer around to the west. I'm going to talk about veering and backing here in a moment. Again, we can see how the winds are switching around. Backing. If the low is going south of us, the winds are going to back around. They're going counterclockwise. So they're going out of the east to the north to the west. If the low is going north of us, they're going to veer. Veer again means that they're going to out of the east, south, west to the north, because they're now under the influences of the high pressure. Again, if it passes north, they veer. If it passes south of us, they back around. The high itself, again, remember this is a big massive air mass here, will tend to be out of the east. When as the front goes by, we're going to get the winds out of the north, west, north. But as it continues to pass by, they're going to veer around to the east and eventually to southwest, which brings us our warm weather. Thunderstorms. Under thunderstorms, you may run into a roll cloud, shelf cloud, and we always have our gust front. So as it approaches, you may have many miles away that shot of air and then quiet. They always talk about the calm before the storm. What you're getting is the gust front off the height of the thunderstorm, but it may also roll up the clouds in front of it. In fact, on the lower right here, it shows you a shelf cloud. When that shelf cloud comes over, you're going to get rain, wind, etc., because they're right underneath the thunderstorm. So as the thunderstorm comes through, we got the gust, we got the shelf cloud, we got light rains, moderate rains, heavy rains, hail, tornadic if it exists, and then clearing. Obviously, again, the lower one is a shelf cloud. The upper one, if you see, you don't want to confuse it with rain shafts. But if I start seeing something rotate and it's low, there's a good chance it may be tornadic in nature of it. The question is, what do you do? Depending upon where you are, besides getting to shore, if you're caught out, they tend to tell you to go through the squall line. This is the front of your boat. This is the strongest, and it gets you through it quicker as well. Lightning. Not good to be out there when you throw your 1/8 ounce jig and it doesn't hit the water. Not good. When you see lightning, if it's within 30 seconds, you're within 6 miles and you're in the danger zone. Not cool. It travels roughly 5 seconds per mile. So you can count out and see how close that is. When you can't hold the graphite rod, when the downriggers are humming and sparking, you really don't want to be out there. Topside icing, again, our bigger boats, it really messes up with the stability. It raises center of gravity and can cause significant problems. That's why boats end up flipping over on it. Okay, quick review. Barometer, pressure, atmospheric anemometer, wind, backing, counterclockwise, veering clockwise. These back around and veer around normally the low rather, excuse me. Passing cold front, wind shift, raising barometer, falling temps. The winds will veer around to the west, northwest. I think we've all seen that. Clouds, cirrus, indicating approach of a warm front. As they descend and fill in, normally in about 12 hours, you're going to see the change. Pressure gradient, horizontal, is going from the high to the low. Isobars, they indicate the spacing of winds and the direction of winds. Wind speed dictated by how tight those bars are. The closer the isobars are, the stronger the gradient, the higher the winds. Stormy weather, dropping or low barometer. Again, we want to see a trend. Passing high, again, winds are switching from the north to the east to south. What does the Coast Guard expect of us as captains? Unlike what the guy did down in Missouri with the duck, we expect them that we're going to listen to the weather. Their expectation is that you're going to listen and monitor one of the stations on your weather radio while underway. You're going to understand any warnings and notices given by the Coast Guard. You're going to obtain weather reports before leaving port, understand all broadcast warnings, and then use the weather information along with weather maps and local knowledge to make sure what's safe out there. So they have an expectation that you're going to kind of have an idea what's going on before you go out and how to respond to it when. Again, we talked about our fronts and our lows and weather changes. I'm going to talk about radio faxes. I'm going to go to here quickly. Now, this is something most likely you will not deal with because it's more intended for ocean. You can download them on your app. You can download, they're off on NOAA's site. But anything listed with an H obviously is high pressure. Anything with an L is low. And they will give you where that is moving in a 12-hour period. So what we have here is, for example, on 1, it's saying the high is going to move from there to where the X is within the next 24 hours. It's going to give you also a pressure change on it. So if you're dealing down in the Gulf and other areas, these are things you really do want to look at. For around here, NOAA's got similar information out on the web for the Great Lakes on it. And that's my quick overview of weather. Any questions?
I don't have any questions. I think we're good.
Okay.